the Assembly and being a research scientist. I am personally very concerned about the effect of drought, heat, all of these things brought on in part by the climate crisis that we have with a combination of warming, drought, and other factors. It used to be that this was a summer issue. Now it's flourishing year round. Drought and excessive water diversions can increase water temperatures, reduce flows, stimulate harmful algal blooms, nutrients found in fertilizer, animal waste, humus waste, also stimulate blooms, and nutrients accumulated in aging reservoirs cause them to suffer blooms in particular. So in 2018 alone, over 100 harmful algal blooms were voluntarily reported to the State Water Board, a twofold increase over 2016. One of the things that I hope will be discussed today is the extent to which the State Water Board has been able to start doing more of this research, more of letting people know where the problems were. So I'd like to, again, thank you very much for having me on today, and hope that we'll learn more as this conference goes on. Thank you very much.
Well, while we're bringing the slides up, I'll give a huge thank you to Bill Quirk for joining us today and for your leadership with the Assembly bill. And hi, everyone. Welcome on this rainy day. I'm Dr. Laurel Larsen. I am the Delta lead scientist, and I'm going to provide just a few words to provide a bit of an overview of this workshop and talk about the goals of the workshop and essentially kick us off today. First of all, I'd like to start by extending a huge thank you to the whole workshop planning committee, chaired by Tricia Lee over here, but including participants from the Central Valley Regional Quality Control Board, the State Water Resources Control Board, Restore the Delta, U.S. Geological Survey, Interagency Ecological Program, Department of Water Resources, University of Minnesota, and California Department of Fish and Wildlife. This has been a huge effort and a great example of a collaborative enterprise. So thank you for making it possible for all of us to come together today. So within this group of organizations, the Delta Science Program does provide a key and unique role. We are really a boundary organization. The mission that the Delta Reform Act tasks us with is to provide the best possible unbiased scientific information to inform water and environmental decision-making in the Delta. We see ourselves as a key organization that implements the vision of one Delta, one science. And this conference is a great example of how we work to bring different organizations together to achieve consensus on the state of the science and essentially provide a framework or recommendations for a framework on how we might move forward with this critical issue. The Delta Science Program has a number of core functions that the Delta Reform Act tasks us with. So I mentioned leadership and collaborative science. We also fund science through a biennial proposal solicitation and also a biennial solicitation for Delta Science Fellows, which fund master's students through postdoctoral scholars. We play a key role in science communication, including workshops and conferences. Everything okay? Oh, no. Okay. We'll take a pause. Maybe I could continue to talk through some of this. We also serve as liaisons to the community for supporting adaptive management. We provide early consultation services to different agencies hoping to implement adaptive management plans, and we convene an interagency adaptive management integration team as well. We play a key role in synthesis. This includes written products. Workshops are a form of synthesis in and of themselves. We also convene training in partnership with groups like the National Center for Ecological Analysis and Synthesis. We provide support for the Independent Science Board, which provides independent reviews of science programs occurring within the Delta, and we provide peer review and advice through convening independent peer review panels ourselves. So our workshops, as I mentioned, fall into the core functions of science communication and science synthesis. They provide us with an opportunity to work towards a harmonized understanding of what the state of the science or the best available science is for a particular topic. And one thing that we view as a really important function of workshops is bringing the community together, allowing for a collaborative approach to capture diverse voices that usually aren't at the decision-making table, and achieve a shared vision. The topic of the present workshop, as I hope you all know, that's weird, is harmful algal blooms. This seems to be doing things other than what I'm telling it to do. Okay, Tabitha, I'm not going to touch the computer. Let's move forward one, please. Is harmful algal blooms. And I think I'm preaching to the choir here on why this is a topic of interest. This has been in national news lately, particularly with the bloom of Heterosigma akishawa that we saw in the Bay just a few months ago, which caused extensive fish kills. But freshwater harmful algal blooms are also increasing in prominence and becoming quite noteworthy within the state. HABs in the Delta, freshwater cyanobacterial HABs, have been occurring every year since 2010. And warming conditions related to drought and climate change may worsen the occurrence of harmful algal blooms in the Delta. Later this morning, you will hear a more detailed history of harmful algal blooms within the Delta from guest speaker, Dr. Peggy Lehman. Despite the fact that harmful algal blooms are prominent and increasing in frequency, there is no consistent HABs monitoring that is conducted or funded. And although sampling does occur by a variety of entities, there is a need for increased coordination amongst the many groups working on harmful algal blooms in the Delta. Next slide, please. So the goal of the present workshop is to inform the development of a Delta region-specific harmful algal blooms monitoring strategy that would serve as a framework for monitoring, modeling, and addressing current knowledge gaps. Now, the recent occurrence of the harmful algal bloom within the Bay also highlighted the importance of considering a region that extends beyond the Delta, considering the estuary as a connected system. And so we will be, throughout the workshop, exploring various opportunities for coordinating and aligning this strategy with the HABs monitoring that occurs within the Bay. Next slide. I'd like to emphasize that harmful algal blooms is a very important priority for us that features prominently in our key strategic documents, as well as within the estuary blueprint. Now, the Delta Science Strategy is currently considered to be a trifecta of planning, which takes place through the Delta Science Plan, focusing research efforts and prioritizing those research efforts through the Science Action Agenda, and then reporting on the state of the science through the State of the Bay Delta Science document. Could you just toggle that, please? And then, so I'm just going to very briefly highlight how harmful algal blooms features prominently in two of these documents. Next slide. And I'll start with the upcoming State of the Bay Delta Science Edition. This is released as a special issue of San Francisco Estuary and Watershed Sciences. Historically, we have released the State of the Bay Delta science on a frequency of every 4 to 5 years. We're moving towards a 2-year frequency that's focused on specific topics. And so next month, you will see a release of the 2022 edition of State of the Bay Delta Science, which is focused on ecosystem services and disservices of primary producers in the Delta. That edition features a chapter that is focused on status, trends, and drivers of harmful algal blooms along the marine to freshwater gradient in the San Francisco Bay Delta system. That's lead authored by Dr. Rafe Kudela. Here is just a quick snapshot of one of the figures in that edition. Next slide. HABS also features prominently in the 2022 to 2026 Science Action Agenda, which guides funding priorities for the science community. There are 2 actions in that Science Action Agenda that focus on HABS. One, the first one, 2B, is highly aligned with the goals of this workshop. It's to develop a framework for monitoring, modeling, and information dissemination, ultimately in support of operational forecasting and near real-time visualization of the extent, toxicity, and health impacts of HABs. And there's another action that focuses on really understanding what triggers particular HABs in particular places within the Delta. Determine how environmental drivers like nutrients, temperature, water residence time interact to cause HABs in the Delta, and also identify the impact of those events on human and ecosystem health and well-being, and test possible mitigation strategies. So no small order there. Next slide, please. I also want to point out that the Science Action Agenda is strongly aligned with the Estuary Blueprint, and HABS also features prominently in the recent release of the Estuary Blueprint in 2022. There's an action or a task that falls within Action 20 focused on nutrient management, and that task is to develop a framework for monitoring, modeling, and disseminating information on the extent, severity, and impacts of harmful algal blooms within the Delta. The next slide. So that concludes my remarks. And again, thank you to all of the attendees who are here in the room and attending virtually. We are very much looking forward to the action items that will come out of this workshop. And with that, I am going to introduce Dr. Peggy Lehman, who recently retired from the Department of Water Resources after well over 34 years of service. Her areas of expertise are phytoplankton ecology, and most recently, she has distinguished herself by being one of the key researchers on harmful algal blooms within the Bay Delta system. So Peggy, thank you for joining us, and forward to your talk.
Okay, thank you. First slide. Today I'm going to give you a history of the Microcystis blooms that I've experienced firsthand over the past 20 years in the Delta. Next one. There are many people who have contributed to this work, and here are listed are some of them. We've got grants to do this work. We were funded by individual agencies, and importantly, all this work was done as special studies. There was no monitoring program per se for any of them. Next slide. So let's start with Microcystis, the basics. I think everyone should start from a basic concept of where we are. Next slide. It's hard, I'm not used to doing the slides here. Well, what is it? I want everybody to really get in their mind that this is a bacteria. It is not an algae. Microcystis contains cyanopigments, therefore it can photosynthesize. It's green, it's in the water, so people used to call it a blue-green algae, but it is not. It is a bacteria, and as such, it is more harmful than a phytoplankton would ever be. It can occur as single cells, which are pretty small. They're like 4 to 6 micrometers in diameter. It usually occurs in the surface in very large colonies. These colonies are large here probably because we have a lot of calcium, but these are very large colonies. People often describe them as looking a bit like cornflakes or bigger in the water column. As you go down the water column, they're a little bit smaller colonies, and they'll go all the way to the bottom. Microcystis vertically migrates each day from the bottom sediments up to the surface. It'll stay there throughout the daylight hours and then move down back to the bottom. It also stays on the sediment during the winter months. Microcystis can form scums, and we've all seen a bunch of pictures of that lately, and it is toxic. Next slide. So why do I say it's toxic? Well, Microcystis contains something called microcystins. So far, we've seen something like 13 or so microcystins in Microcystis. Not all of them are toxic, but there's one that we consistently see in these blooms. It's called microcystin LR, and it is toxic. You can see that here in this figure. It's the pink color. So pretty much we've always seen it to be toxic. Next slide. And it's highly toxic these days, which is why, of course, we are having this meeting. In 2020, we found that microcystin levels reached dangerous levels in the Delta. The Stockton Ship Channel was an area where we saw dangerous levels, as well as Discovery Bay, even in the lower San Joaquin River. Reports that these values reached as high as 1,000 micrograms per liter were common during this period. So we not only have a bloom, we have a very dangerous bloom these days. Next slide. The bloom itself is primarily concentrated in the central delta and southern delta, but we have tracked this bloom throughout the delta. We have tracked it as far as Martinez and Benicia. Salinities in these areas were 18. Microcystis is now known to inhabit estuarine areas. It's expanding to those areas worldwide. So salt is not necessarily a barrier. And if you look at some of Martha Satula's work, we also know that we find Microcystis down in the bay. Next slide. So what's the history of this? Next slide. People constantly ask me, is this an invasive species? And it's not. Microcystis occurs worldwide, and it's considered to be ubiquitous. I found Microcystis listed for our estuary by Winfred Allen in a publication he did in 1920. He was measuring Microcystis in the San Joaquin River, just about where we sample now, around Buckley Cove. And there he did see Microcystis in 1913 during the summer, during the fall, and even had samples showing Microcystis in the winter. In the EMP, or the Environmental Monitoring Program database, I've encountered Microcystis listed in 2003, although that might be deceiving because the magnifications were fairly low in the early years of that database. So Microcystis could have been there in small colonies. Plus, Microcystis often occurs really at the surface, and they don't sample that surface layer. So it's not that it wasn't there, but it doesn't really show up until about 2003. But in 1999, people were out in the water. They informed me that we had these very large colonies. We looked to find out what it was, and it turned out to be Microcystis. No one had ever seen these large colonies before, these kind of cornflake-looking colonies in the surface of the water. Knowing phytoplankton and cyanobacteria, I said, well, let's just wait and see. And it kept coming back year after year. So in 2003, I got some funding from NOAA, their special emergency program, as well as from the Department of Water Resources. And we did our first initial study. Next slide. What we found was that Microcystis in our water system was just Microcystis aeruginosa. It was very unusual. Usually there are a lot of Microcystis species and a lot of strains. We had none of that, just this one. But the bloom progressed very rapidly. And our studies from 2008, 2012 demonstrated that now we had multiple species of Microcystis, as well as multiple strains of Microcystis. A very fast progression of this bloom. Next slide. Today, we have a very developed cyanobacteria bloom. It has multiple species of cyanobacteria. It has, so we have Dulcosperum, for instance, a phenozomenon. We have multiple species of Microcystis. Plus, as Tomo Kurobe and Tim Otten will say, we have at least 10 strains of Microcystis aeruginosa. So this bloom is developing into our system, expanding into our system, and bringing in a lot of other species that it likes to be with, so to speak, or likes to be with it. And as a part of that expansion, we're seeing a lot more toxins. So we're seeing the microcystin toxin that we know is there, but we're also seeing anatoxins as well as saxitoxins. And these are slightly different. Microcystin is a hepatotoxin, so it affects the liver. Anatoxins and saxitoxins are neurotoxins, so they affect the nerve system. So we're getting a broader sweep of impacts to the species that are in the delta. Next slide. So what are some of the controlling factors? Next slide. Well, Microcystis is well known to utilize ammonium very effectively. It can uptake ammonium faster than any other plankton in the water column. So it grows very well when there's a lot of ammonium. And in our work, what we found was that as the percentage of ammonium increased, the total nitrogen in the nitrogen pool, then there was more Microcystis. But I want to caution everyone that although ammonium is not a good thing to have in our system, Microcystis doesn't really care. Our isotope work indicated that it will grow on anything that's there. It utilizes nitrate as well as ammonium very well and will switch it between one to the other depending upon what's available. A characteristic of Microcystis is that it occurs where temperatures are warm. So in our system, Microcystis comes up from the bottom sediments when temperatures reach 19 degrees. It'll stay in the surface waters throughout the summer and fall until water temperatures drop to below 15 degrees. And it will stay in the sediments then until the next season. Microcystis also is very capable of migrating vertically in the water column, and therefore it can control its light. It likes to be on the surface later. So there's no issue really with light availability, but we did find that when total suspended solids were about 20 milligrams per liter, we did see more Microcystis. Probably because it's affecting the Microcystis within the water column rather than the surface. So right now, there's a lot of interest in the nutrients and the nutrient ratios. A number of people have been looking at this. You'll see that Francis Wilkerson and Pat Glibbert have done some work. We did some work. Hans Perl is now doing some work. We're all doing bioassays to figure out what the best combination of nutrients would be to enhance phytoplankton and decrease cyanobacterial. It's a very important work and ongoing. We'll see what comes of that. Next slide. But I want to caution everyone that what happens in the water column is not due to one variable. It's due to a combination of variables. And at any given time, one variable may be more important than another. So take, for instance, here, one of the things that we found is if you look at water temperature and residence time, kind of proxied by the X2 index, that at a certain level of the X2 index and a certain water temperature, you can get the maximum Microcystis. But that could change from day to day. Next slide. An important consideration in San Francisco estuary is this is an urbanized estuary. And we are putting in a lot of toxic substances into the water column. One of the things we wanted to know was if the herbicides that are being put in the system could impact the Microcystis blooms. And what we found that was fluoridone in ambient concentrations enhanced Microcystis growth and inhibited Thalassiocyra growth. The Thalassiocyra is a diatom that we would like to see in the system, desirable. So we really have to be careful the kinds of things that we're putting into the water column and how that may impact our plankton community. Next slide. So what are the impacts? Next slide. Well, we can start at the base of the food web with the photosynthetic plankton. When Microcystis is present, it brings in a lot of other cyanobacteria with it, right? And it's likely, because of its allelopathic properties, to inhibit desirable phytoplankton like diatoms and green algae, and perhaps enhance cryptophytes. This varies with wet and dry conditions, so the drier the conditions, the more likely this patterns will occur. In wet conditions, we usually see less Microcystis and more of the desirable species, such as diatoms and green algae. But I want to point out one important thing. The cyanobacteria are not bad. A lot of the cyanobacteria we have in the system are really good. They may not be very good in terms of their nutrition, but they're not bad. They're not toxic. So just cyanobacteria alone in the system is not bad. So we need to be careful that we're looking at, toxic species and not just cyanobacteria as a tool. Next slide. As you go up the food web, we see that there are effects on nutrition due to composition. So for instance, in this study, they found that as the Microcystin concentration increased, the zooplankton mortality increased, but it was species dependent. So Pseudoactinus was more affected than Eurytemra. And of course, when you see these shifts, you not only are seeing, a loss of total mass, but you're also seeing a shift in the quality of the food that's available. Each zooplankton is not the same. Next slide. Sorry. Well, we did some metagenomic analysis looking at the plankton community. What we found is that when Microcystis is present, there's a real structure to the community. The cyanobacteria aggregate together with Microcystis. They vary with it. So during a Microcystis bloom, you'll see a lot of cyanobacteria like Aphanosomnon, Sphaerospermopsis, Pseudoanabana, Dulcispermum, Planktotrix. You'll see small zooplankton like Paracyclopina, Limnothoina. A few green algae, Bullfox, Chlamydomonas, and a very few bacteria. An interesting component of the bacteria is something called Phenylobacteria. It varies directly with the cyanobacteria cluster. We found that in our work, and Tim Monton noted it in his work, same thing. Phenylobacterium is a bacterium that eats or digests inorganic substances. So it could digest chemicals in the water column, herbicides, things like that. And it varies directly with the cyanobacteria. It suggests that maybe one of the things that we should make sure we check on is if there aren't any substances we are adding to the water column that could be enhancing cyanobacteria bloom. We are an urbanized estuary and we need to be careful what we do. Next slide. As we move up the food chain, of course, fish are important to us. And laboratory studies have demonstrated things like threadfin shad and split tail are not healthy. They have a low condition factor when they're fed a diet of Microcystis. So threadfin shad, for instance, some of that's visual. They have a cavitated body, curvature of the spine. But Ashanakuna has demonstrated it doesn't have to be fed directly to the fish for it to have an impact. When the fish is swimming through the water, the Microcystis enters through the gill, gets in the digestive system, and then passes into the organs where it causes death of the liver through necrosis of the cells. So just being in the water, even at low concentration, can impact these fish. Next slide. Microcystis occurs throughout the food web and therefore poses a threat. There hasn't been an organism that I've examined yet that hasn't contained microcystis. However, there's another component that we really need to consider that isn't quite as obvious, and is that there's a dose effect. So if a predator is eating a prey, say an amphipod, that has a little bit of microcystis in it, that's one thing. But when it eats 20 or 30 or 40 or whatever amphipods, then it's getting a large dose. This is particularly important for something like threadfin shad, which is a popular prey item. Threadfin shad loves microcystis. It stuffs its body with microcystis till its stomach is distended and it looks green from the side. So a predator eating a threadfin shad is going to get a very large dose of microcystin and therefore is at risk. Next slide. Well, where does all this leave us? Next slide. We've got a lot of information. The past 20 years, we've come up with a good bit to help in the challenge we have in the future. We know something about the distribution and abundance. We know some things about the controlling factors. We know what the toxins are, what some of the food web connections are. We've got a handle on the genetics and how to measure those genetics. And we know a little bit about how climate change may impact the blooms. Next slide. But right now, we need to focus on some other things. Because the bloom is now dangerous, we need to focus on safety. We need in situ, real-time monitoring of species composition and toxic concentration, as well as real-time information transfer to web-based systems so that the public and scientists on a daily basis know where the toxicity is. We can enhance some of this perhaps by taking some guidance from some of the coastal communities who are working with dinoflagellate blooms. They use forecast modeling to help them know what's going to happen within a few days. I think that there's a whole lot there we can learn from our colleagues who are working with these dino blooms. Next slide. We have a continuing need to develop management techniques. We need to know what nutrients we should or should not have in the system and what concentrations and ratios. We need to find out if we've got some treatment systems that we can use. And we have to do things that can help us reduce drought impact. Next slide. We also need to continue monitoring new cyanobacteria species and their toxins are coming into the system. As you can see, it's a rapidly evolving cyanobacteria bloom. The distribution is going to shift, particularly as salinity shifts in the system. And environmental conditions are ever changing now because of this climate shift we're seeing. So we've got a lot to do there. Next slide. But I want to make sure we understand an important component here is that we are not alone. Throughout the world, Microcystis is the most fastest growing toxic organism in fresh waters. There are a lot of people who are experiencing exactly the same thing we are. We can learn from them, work with them to deal with our problems. So we need to collaborate a lot. Next slide. And the future, I think we need to focus on other challenges. There are a lot of toxic or potentially toxic species in the upper estuary. And we need to be prepared that one of these may become more important tomorrow compared to today. This is a graph of the environmental program monitoring data between
So sorry to interrupt. I think we've lost the audio in the room.
We need to be careful because there are a lot of other species out there, and we need to plan for future bloom challenges. Excellent. Thank you. And I can take a few questions. That's good. We can move along. Oh. Hi, yeah. Right, it is, but not undoable. If you look, here's where collaboration comes into play. If you look along the coast, all the work that's being done with dinoflagellates, they are actively working with in situ systems, doing toxins, as well as species composition. They're doing it today, every day, and have been doing it for years. So a lot to learn there. It's not easy, but certainly it can be done. And they're doing it now. Yes. Well, yeah, I think a lot of people for dinoflagellates using the cytobots. Oh yeah, the question that Tamara asked was, it's a challenge. She said it's a challenge to measure species composition and toxin concentrations. You know, any ways that you can do that, and of course, we all know about the cytobot, which is in situ flow cytometer, basically, that will take images of the phytoplankton or cyanos or whatever, and can quantify it actually. There's also, I think I'm going to get it wrong, and Keith, you can correct me, SP, which measures toxins. It's a wet lab technique, and it's in situ. But as I say, these are being done. They're being done in the Northwest. They're being done along the Gulf. They're being on Florida is a big area with have Carina issues. So there's a lot that we can draw from. They have these monitoring systems that are set out there, and they work for months at a time, and they provide information by satellite into computer systems on land. So it's there. The technology is there. Not easy, but it's there.
Okay, I have an online question, which you'll also have to repeat for that. But the online question is from Wusong Jin asks, are there conditions for microcystis to produce microcystis or specific toxic forms of microcystis?
The question was, are there conditions that produce microcystins or toxic forms of microcystis? Well, if we could figure that out, we'd be in good shape. I don't think that that's well known. As far as I know, at this time, there's a lot of hypotheses, lots of studying, but no absolute answer to that question. Yeah. The question was, is there a way to measure the levels of toxins in the sediment during the winter? I imagine that you could just do a core. Yeah, I don't see any reason why you couldn't do that. Yeah. There was one work actually that did that, Bolatello. I remember the name. Actually, he's done something that's published 2020. Check it out.
So I believe Mary Scudder has her hand raised online.
Okay.
Hi, my name is Mary Seltzer. I'm the manager for the Cultural Heritage and Environmental Protection Departments here at North Fork Rancheria, Mono Indians. We're located in North Fork, California. Our homelands are the headwaters of the San Joaquin, but as some of you may know or may not know, we have reservoirs, streams, you know, everything around here, drainages, natural drainages. But one thing that I am not a scientist, okay? I have absolutely little to no knowledge about this, but I am trying to learn because we heard of a harmful algal bloom in the Merced River last year. And I don't know the specifics of it, but one of the things that has been on my radar is the fact with the drought, and we're seeing just the condition of our lakes and streams and reservoirs up here is depleted. You know, it's getting bad, the water quality. So what I would like to know is if there's been any studies or anything that we can do as a tribe, that because we are not scientists. We have no we have traditional tribal monitoring, you know, water monitoring, but traditionally, not as what has been spoken here and mentioned. And I just wanted to know if there's any advice that you could give the tribal community, specifically ourselves, as to how we can kind of get ahead of this. We're also
I think the question is, I'm going to go to the very end here, is how could the Native American community help to reduce TAB?
Yeah, and
well, I am going to punt to you, because I would say that as a community, you know better how to stewardship the land than a lot of other people do. I think that you guys can go through your heritage and work through the health and just collaborate with all of us out here struggling to figure this out. But I do think that the Native communities have a better sense of how to do some of this. I think we just all have to work together. I think that's the key, working together to solve the problem.
Yes,
Thank you.
I appreciate it.
Great, thank you, Peggy. We're out of time for questions, but I know there were a lot more in the chat, so there's a chance we may be able to address those at a later time. So, can I get the next slide, please? And the next slide after that. Okay. Oh wait, yeah. All right, so thank you, everyone. Thank you, Peggy, especially. That was an excellent talk. I really appreciate you taking the time to give us all that information this morning. We're just getting started, though. We have many more presentations this morning, as well as a panel. I'm Tricia Lee. If you haven't met me, I'm a senior environmental scientist here at the Delta Science Program. I'm starting us off this morning to just go through kind of how this workshop came about and set the scene for the upcoming talks. So next slide, please. All right, so this, the draft strategy that was posted online, this is something that the planning team for this workshop has been working on since December 2021. We've been meeting monthly to discuss the different management questions that would guide a monitoring strategy that could be used by the community of the Delta. Many of the folks whose logos are listed here were participants on that planning team and have really contributed a lot of their great feedback and information to develop this draft strategy that we're continuing to work on. Next slide. And so, of course, we did not develop this in a vacuum. We had a lot of references that we leaned on to help us develop this monitoring strategy. We took our cues from lots of external sources, including Assembly Bill 834, which directed the development of the FPAB program. The FPAB program itself, we had some members from that program that were participating on the planning team. The collaborative strategy that was called the Statewide FPAB Framework and Monitoring Strategy, which was published in 2021. We also referenced and used the Delta RMP Nutrient Research Plan in order to develop our management questions, as well as the Delta Science Program has their own science action agenda, which called for some of the those actions that Laurel, Larsen discussed this morning. Next slide. So the Statewide HAB program you'll hear more about in a little bit. It was funded in 2020, and we really were able to helped us to kind of they gave us a lot of the background information and baseline information that we would be able to use so that we didn't have to reinvent the wheel for a lot of the recommendations. Next slide. As well as these two journal articles. I know Laurel spoke earlier about the upcoming State of the Delta Science chapter by Kudela et al. We also referenced an additional paper which came out earlier this year by Howard et al., which was an integrative monitoring strategy for marine and freshwater harmful algal blooms. These two articles provided some recommendations which we tried to incorporate into this draft monitoring strategy. One from both the Kudela et al. And Howard et al., there was a recommendation to develop some kind of strategy, which is what we're hoping to do here. And then an additional recommendation from Kudela et al. Was to include both short and long-term management and mitigation approaches. So we're keeping that in mind. And the Howard et al. Paper also recommended that we include multiple sample types and toxins. These are things that we're keeping in mind as we develop these monitoring strategies, to really lean on this monitoring strategy, to lean on these external sources. Next slide. We also recognize that there's so much work to be done on harmful algal blooms. We really needed to focus this strategy in on specific goals, which meant being explicit about what we couldn't cover in this strategy at this time. So our strategy, you'll see in the draft document, which is available here and online, that we are not going to be able to cover informing the development of thresholds of harmful algal bloom toxins on drinking water or human food sources. We are not going to cover impacts of contaminated water by harmful algal blooms on agriculture, or to a large extent marine harmful algal blooms. The impacts of harmful algal blooms on food web dynamics and the public health epidemiology as a result of chronic or acute HAB exposure. However, the strategy could someday lead to covering these topics. This is just what we felt we could start with for now. Next slide. So some management questions that are driving this monitoring strategy, which are also included in the draft document. The primary management question we had was, how can HAB monitoring be collaboratively designed, facilitated, integrated, performed, and/or standardized to achieve status and trend monitoring objectives, and to fit the scale of management actions, timing of ecosystem processes, and climate change challenges. So there's a lot in there. The definitions of status and trends are included. And then another question to kind of support this is just, what are the drivers of HABs in distinct areas of the Delta to inform management actions? So next slide. So we further refine these into smaller chunks to bite off over the next 2 days. Day one, we're focusing on collaboration. How can this collaboration piece be integrated into this strategy? We're working around these 3 questions. How will the HAB strategy communicate and link with existing strategies and efforts? What are the existing barriers to collaboration amongst groups? How can we overcome them? How should safety and health risks for human and domestic animals be communicated? So some of this collaboration, how do we work together, and how do we communicate effectively? Okay. And then tomorrow's focus, we're going to bite off additional pieces on data sharing. So how can relevant data be made accessible and available to different groups? And how can current barriers to data storage and access be overcome to support a comprehensive monitoring program? Next slide. So that's a very quick high-level overview of what we're going to get into. Now I have an interactive piece, so I hope you're all awake and ready. Please go, if you have a phone or a computer, and people online, please also do this. Go to menti.com, that's menti.com, and enter this code so that we can get a poll of our audience members, both inline and virtually, to better understand what individuals in the audience here today, what your desired outcomes of a coordinated monitoring strategy are. You can select up to 3. 1 moment to do this, and we're going to share the results later. Okay, I'm going to move on. Next slide, please. All right, with that, thank you everyone for your attendance. We're really excited to see this workshop happening and to gather information from all of you attendees to build into the strategy. And with that, I am going to hand it over to Marisa VanDyke to take us into the next topic.
Hey Tricia, just want to check my audio for those of you in the room. How's it coming through?
I'm sorry, what was that?
Want to check my audio in the room before I get started? You know, in Zoom, you guys can hear me.
That's
about it.
Just want to give a moment for switching for the room audio, folks. So while they're getting set up, this is Marisa VanDyke. I'm with the State Water Board, or collectively the California Water Boards. I'm helping Tricia moderate this session. And I'm going to be representing for the virtual end because a little health conflict that came up, unexpected. And Tricia's going to be taking care of the questions in person, and then I'm going to be trying to handle the questions that are over Zoom. How's the audio? Can we get started from the virtual side?
Yeah, go ahead, Marisa.
Can we? I couldn't hear you, Tricia.
I just said we're good. Go ahead.
Okay, great. All right. So with this session, you know, we're taking a close look on how to create a coordinated monitoring strategy. And in particular, you know, we just heard some starting management questions to help frame the scope of the strategic effort. And we're going to hear in this session about some other strategic efforts for monitoring that have framework and some recommendations that we can consider for your own plan in developing your own plan in the Delta. We're also going to learn a little bit more about existing monitoring that's occurring, where you can get the data, and some example of HAB assessments that have been happening the past year. And we're going to hopefully have time for questions after each presenter. So please feel free to throw your questions in the Zoom chat so we can keep track of them. All right, next slide. All right, so in my talk, we felt that we wanted to provide an overview of the bill's objectives that we heard about today from Assemblymember Quirk, Assembly Bill 834, because there's directives to state agencies to build out much infrastructure that then could be leveraged for regional and watershed scale initiatives to address HABs. Specifically, the infrastructure that's being built to support monitoring that this Delta monitoring framework can leverage. And also you can participate in developing out the infrastructure that state-led agencies are building so that it can also work for you and your initiatives as well. We're also going to touch on kind of like the regulatory policy context to build on what Laurel has shared that prompted this workshop, and throw in a little bit of Water Board's perspective. There's some regulations under development that can kind of change the regulatory requirements for monitoring in the Delta. So it can help provide resources indirectly as well to leverage with a collaborative plan. Next slide. And next slide. All right, so first we wanted to highlight, what is this program? What's it been doing? What's going to be doing? So I represent the California Water Boards and the Freshwater and Estuarine Harmful Algal Bloom program. We call this FHAB for short. Many of us call this FHAB frequently, so that's going to be a commonly used term. And we closely collaborate with the regional water boards across the state to implement this program. It's housed in the Office of SWAMP, which is the Surface Water Ambient Monitoring Program. And before the bill, there was a smaller scale program, and we were designated the lead to respond to incidents of blooms that reported from the public. And so that was the initial purpose of the program, to coordinate response to the bloom, assess it, communicate risks with the local agencies and the public. There we focus mostly on recreational exposures and then how that's impacting source water. So it has some overlap with, again, informing drinking water uses. Through the Assembly bill that passed, the program became formalized and received permanent full-time staff and funding. The staff were in place by the summer of 2021, so not too recent, but a little bit recent to us. And so the scope of the programs has significantly expanded. Next slide. With that expansion, as I said, we have a full-time staff that we closely collaborate with at the regional water boards. And in particular for the Delta, Karen Atkins is the FHAB coordinator for the Central Valley, and she'll be presenting later today about later in the session. So you'll be introduced to her. And you can contact any of us through the California HABs portal. We have a state agency contact, so feel free to reach out to us. Next slide. And when I mention again, the California HABs portal, that is a centralized website that is run by the CCHAB network, a statewide effort to coordinate on HABs. And many of the pages are managed by the FHAB program to host content that's developed by partner state agencies, organizations, many different groups. We help put it onto the portal, manage that content, and there's a lot of tools and resources to leverage, particularly to answer kind of four larger questions. First off, where are HABs? There's some mapping tools. So we have a map that shows reports of where reports are coming in, updates to those investigations. We also showcase monitoring data that is shared with us from other partner entities that are monitoring around the state and in the Delta. So you can take a look at that. We're going to be working on improving that map to better showcase monitoring data alone outside of the reports this winter. So please reach out to us if you're interested in that. We also have a tool that showcases processed satellite imagery or cyanobacteria abundance, and some parts of the Delta can be seen with that. We also have resources on how to inform the public on how to stay safe, how to protect their family, also about wildlife impacts, livestock impacts, and communication tools. There's also a standardized approach or field guide for how to collect samples and interpret what that means, cyanobacteria species, the toxins, what it means, and impacts to recreational use. And so to pull that together, there's a response plan that we can implement along with local agencies to how we communicate, what steps we take to post advisories, to take down advisories. And in that guidance where the response plan is hosted, there's also pre-made signs and that kind of framework to implement for incident response. Next slide. All right, next slide. Okay, so we're gonna get into the Assembly bill's objectives. Incident response is only one of the mandates specified in the bill. So there's much more strategizing and planning that we've done and need to still do with collaborating entities to work towards addressing the range of objectives, and really at multiple scales. They're quite comprehensive. Fortunately, with these mandates came some additional resources. 2 agencies requested and received permanent full-time staff. That's at the water boards and the Department of Fish and Wildlife. And the water boards also got annual contracting funds to help work towards these objectives. Though there's not enough resources to comprehensively address all of the mandates yet, we're looking forward to considering how this dedicated staff and can work together with all the different collaborating entities and agencies to improve FHAB response, and monitoring, and research at the local and regional scales. So we're going to take a close look at those objectives. Next slide. So the first objective, consultation, what we kind of call collaboration. It's really the foundation to the success of the program. It requires collaboration with many different state and federal agencies listed here. Also the California Native American tribes, really important to collaborate with. Many tribes have also been monitoring for a longer time than many state agencies, and are really great collaboration entities. We also see that nonprofits and citizen monitoring groups are not reflected in this consultation group and really are great partners as well. So we've been working towards collaborating with a whole host of entities. So if you haven't been reached out to, please reach out to us. And we're going to continue reaching out and collaborate, figuring out how we can coordinate in the winter and early spring months. Next slide. Oh, sorry. See there, you already went. Okay. The second objective is incident response. So something that we've been working on really well is that immediate incident response. This objective also includes long-term, so that follow-up response as the plume is ongoing until it subsides, continuing the monitoring to inform risks, what the risk is to the public, and communicate with local decision makers and notify them. So that's another really important objective. Next slide. And to do incident response, really important is to have a standardized approach that we can implement statewide and be consistent again with our local agencies, particularly public health and environmental health. We've been implementing what CCHAB Network developed back in 2016. They developed a voluntary cyanobacteria HAB guidance for recreational waters. In that, they have a tiered advisory system based off of cyanobacteria species, abundance, and cyanotoxins in water. They have triggers for posting, flow charts, and also pre-made signs for benthic and planktonic bloom signage. Next slide. Great. So the next kind of two objectives are quite complementary to each other. One is, of course, monitoring, comprehensive monitoring statewide at many different scales to assess the spatial extent of HABs, the status or magnitude of HABs, and then the trends over time. Is it improving? Is it decreasing? What time of the year? Is it most abundant? That kind of thing. And what helps inform how to prioritize monitoring is also through risk assessment, as with that other objective below, if you can go back one slide. And with risk assessment, it'll help prioritize which monitoring assessment at those waterways that are already at risk or could be at risk, and also focus remediation and risk management practices on those water bodies. Next slide. And with this bill coming, we are trying to prepare for that, and as a result of the bill, we launched a multi-year effort along with HAB experts, national HAB experts, and with state agencies to develop a strategy and a framework on how to do comprehensive statewide monitoring and what research is needed to fill in those gaps of knowledge. So because we understand that HABs have been increasing in California, as we've been hearing, they're lasting longer. We really need to quantify what the impacts are, what the risk is. And it's difficult to quantify those impacts to a whole range of different uses without monitoring data to really understand what the problem is. So we worked together in a collaborative way to develop a strategic approach. That report was published last year, and we're going to take a deep dive in that with the next presenter, Jayme Smith. And next slide. We wanted to highlight, and she will as well, one of the key recommendations that came out of that strategic effort is to develop a full-fledged partner monitoring program. Because as we hear, not just from in the state, but also other states, HABs are too big and too complex of a problem for any one agency to address. It's not just a water quality issue, it's not just an environmental quality issue. It's impacting many different uses, and it's a food web and so forth. So really takes the resources, the know-how, of many different entities and organizations to come together to address this problem. And so with that, we're building out the partner monitoring program, which some of you might have already heard about, because we're building out infrastructure, particularly data management, data repository. We're going to hear from Greg Earhart about that tomorrow. We're also seeking participants on doing partner monitoring. For example, we're doing pre-holiday assessments during the warmer months 3 times a year. We have some resources to share with those participants. So again, we're seeking participants, and through that, we're building out standardized procedures to collect measurements. So stay tuned. Next slide. All right, the next objectives, it directs state agencies to work on research, fill in those gaps of the known unknowns that we have to answer, like we were hearing in some of those questions just now during Peggy Lehman's talk. And we also need to develop tools to support decision support and that kind of thing. Next slide. We need to also expand our outreach and education, maintain centralized website, build out that data infrastructure that's so important to assess the data that's out there and that's being collected for monitoring. Next slide. And reporting is one of the last and fundamental objectives, where we need to report out to legislature and the public on what we've been learning, what actions we've taken, what we still need to take. And our ledger report will be published actually next year for this year's efforts, and includes a gap assessment that we've highlighted. Next slide. All right, so we're just gonna add to the bill and also highlight just kind of like the regulatory context, and again, some pieces or initiatives in that you can leverage in developing your own Delta specific plan. Next slide. So I don't work directly on the regulatory side of things, but we learned that there is an opportunity to leverage the data that's coming from required monitoring through permits, regulations, policy. We can work with them in a collaborative way, because oftentimes we're asking similar questions. We're maybe monitoring the same areas. We can leverage that to meet all of our monitoring goals, or some of our monitoring goals. For example, perhaps there's a monitoring site in the area of interest, and commonly that data is accessible from entities that are required to monitor, but then you can also use to assess. Maybe you can partner with them. So that's, again, a way to leverage. Also, it's good to be aware of what new regulations or policies coming down the line, because it can influence the monitoring in the future that'll be required in your area of interest, especially the Delta. So take a close look at what's being required in the Delta Regional Monitoring Program. There's the biostimulatory policy that's coming, that's going to require cyanobacteria and cyanotoxin monitoring across the state. And with the complex management in the Delta, really thoughtful approach to make a strategy work for the stakeholders and the organizations in there is really important, especially if we're also assessing status and trends along with our required monitoring objectives. It's really important to collaborate to better understand the water quality, identify impaired areas, and start understanding our mitigation measures improving the condition or not. Next slide. And with that, just going to close, since we began tracking the HAB instance statewide, we're seeing that it's increasing. It's really clear that it's occurring in a lot of our priority regions like the Delta and the Bay and the Estuary. And we're, with that, it's also becoming more popular in the news. Also in the Delta, here's some headlines. It's gaining public attention, and also with the legislature. And with this growing need to address the blooms in the Delta, we're coordinating a monitoring framework and that you can leverage. And also we're looking forward to collaborating with organizations and stakeholders in the Delta to develop a plan that works for you and meets your questions. And thank you. All right. Doesn't look like we got any questions virtually. I'm not sure if you have a question in the room. Otherwise, we can go to the next speaker.
I don't think we have time for questions.
Okay. All right, I'll introduce the next speaker. This is Dr. Jayme Smith of the Southern California Coastal Water Research Project, or SCORP. And she's going to be going over the statewide framework and strategy for FHAB monitoring.
Awesome. Yeah, thanks, Marisa. Can you hear me all right?
Yes, we can.
Great. Okay. All right. Yeah. So thank you for that kind introduction. I'll just jump right into it because I know we're a little short on time. If I could go to the next slide. So I think it's clear to everyone that ambient monitoring for HABs is a difficult thing to do. it has a lot of logistical challenges. And so I'm talking to you about the statewide program, which I think shares many of the same challenges of the Delta, if not, over a larger spatial scale, but hoping that you can draw some similarities and some inspiration from some of the work that has kind of already been done. So as we've kind of heard, that blooms can be ephemeral or long lasting. They can occur in any season. They can occur across a diverse array of environments, across salinity gradients, basically in all aquatic systems, including, as you are aware from the recent kind of bloom events up in marine systems, all the way down into the low salinity regions of the Delta. So if you can go to next slide. So coordination and strategy really helps with overcoming these challenges. And so I'm going to tell you two stories about coordination and strategy. So on the next slide. So just a quick note on an existing program that has been running for about 15 years now, is California HabMap on the marine side. So I have a pointer to a paper that's talking about the details of this, but essentially, in the early 2000s on the California's coast, marine hab research and monitoring was very isolated to subregions. There were a lot of work being done across the coastline, but people were using various field protocols, different lab protocols, and it was really difficult when people would start to maybe try to come together and compare notes. So very similar situation. And so in about 2007, the HabMap, which is the Harmful Algal Bloom Mapping and Response Program, or Alert Program rather, was developed and was implemented. It's now still running. We have 9 different sites along the California coastline where weekly HAB monitoring is happening off of piers. It has been used in several dozen research studies, provides a weekly update to stakeholders, California Department of Public Health, marine mammal stranding networks, and dischargers, as well as now being integrated into things like the monthly HAB bulletin on the marine side. And all of this was possible due to the coordination and concerted effort to kind of unify field protocols, lab protocols, and coordinate efforts. So if you can go to the next slide. And that's a wonderful story, and I think it's inspirational. And I think that, part of the success with coordinating is determining and having a clear vision of what to coordinate. And so I think the recently published FHAB monitoring strategy, which we'll spend the rest of today or rest of my talk discussing, is a good kind of framework for how that works. So we built a framework, as Marisa kind of alluded to, a framework and strategy to coordinate efforts. And that was, the reason to do that is ensure that monitoring efforts are designed and implemented in a synergistic way towards a common goal, and that those common goals are clearly articulated, and efforts remain organized and question driven, meaning, everything is kind of done with a purpose and using resources appropriately. And so the FHAB strategy, the purpose of it and the framework and strategy was to clearly articulate and those questions and management linkages, identify the beneficial uses, and Marisa had a nice slide showing the 5 kind of core beneficial uses that were of concern, the water body types and approaches that would all be used to address those questions, as well as developing a vision for implementation. So this figure here on the left-hand side kind of showing how you can put all of those pieces together in a nice cohesive puzzle. So you can go to the next slide. So on the onset of developing the strategy, we had to, like I said, decide on priorities. So if you can go ahead and we'll flip up all 3. I have perfect. Yeah. So for the monitoring strategy, we articulated that we wanted the monitoring strategy to address the 5 kind of core beneficial uses of surface waters. We set, the broad goal of addressing basically lentic and flowing systems, as well as the land-to-sea interface estuarine zones. and that we wanted to employ kind of three main monitoring approaches. So state-led, so things that the state agency like the water boards would be doing. As Marisa mentioned, the partner-led monitoring program, as well as integrating remote sensing tools in order to achieve our vision. So if you can go to the next slide. From that, we thought carefully about the types of information and the kind of end use of that information to create described management questions, which I know several of those have been drafted for the Delta, but just giving an example here of like, this is a pretty expansive vision where we wanted to address status, trends, drivers, incident response, as well as kind of down the road be able to move towards HAB prediction. And so as you can see, I know we're short on time, so we can kind of just use status as an example here. But asking the question of what is the overall magnitude and spatial extent of FHABs within a watershed. We ask these questions across different spatial scales. So I'm showing kind of an adaptation of our watershed questions because that seems particularly relevant to the Delta, and linking that then to types of management decisions that could be made by answering this question, things such as prioritizing watersheds or water bodies for additional monitoring or study, 4 or 5B reporting, briefings to legislator, and status and trends report to the public. So there's like linking, again, trying to link what we're doing with outcomes. Next slide, please. And go ahead and I had 3 animations here. Perfect, thank you. So we did this in a collaborative framework. So we assembled a relatively large technical advisory committee just because it was such a large program. I'm just showing the demographics here. So we have both state and federal agencies and local agencies represented, as well as some NGOs, tribal government representation, and research institutes and academia, in order to get a diverse kind of array of voices of both scientific experts. A lot of our academic partners were our experts that have long histories of research in this area, as well as people that would be implementing or using or benefiting from the strategy, to kind of all weigh in on the framework elements, like so selection of indicators, some proto survey designs and options. Then, of course, you do all these things, you want to be able to support the data outputs and use that in decision support, as well as identifying, leveraging opportunities. Everyone has limited resources, but a lot of agencies have similar goals, as Marisa stated, and so we can use our resources wisely by collaborating and leveraging resources. And all of that kind of come together to form the strategy, which is where we made this comprehensive vision and then laid out, on different timescales when we were going to work on these elements. So next slide, please. So I'll just give you a quick example of kind of how this worked. So we created a conceptual framework of how each of our core beneficial uses were going to be impacted. So if you can go to the next slide, I'm going to just step you through a quick example. So for recreational, or what we called swimmable uses, some of the key ways that uses could be impacted would be with toxin exposure or poor water quality. If you can go to the next slide. So we broke those into indicator groups. We'd want to be able to say something about those types of impacts. So next slide. And so then we linked with our technical advisory group. We identified metrics that would link to those. And the next slide. And then identified what you could then inform based on those measurements. And I think Keith Wilma-Gregson is going to give a talk tomorrow about all these a lot of these detailed metrics. So next slide. So we basically stepped through that process for all of our beneficial uses and came up with our comprehensive vision with our core principles of beneficial use protection, open data, tribal partnerships, and leveraging. So next slide, please. So we ended up with 6 strategic recommendations. If you just do the next slide, I think several of these are very in line with what the Delta group is hoping to establish. And then if we could just skip next slide. So next, sorry, I have animations here. This is how we kind of worked on the strategy, but I know I'm running a little low on time, so we'll just go to the very last slide here. And so I think that through this process, I wanted to highlight a couple of best practices, which includes, we talked a lot about the challenges. I think articulating your clear management goals at the beginning and your questions to guide your program development, establishing a steering committee early that can kind of provide a diverse array of voices and expertise to guide your development and implementation is really critical. Using kind of multiple approaches, and I think we've heard about several of those types of approaches to address your management questions. Partnership, leveraging is great, and partnership allows for us to do more. And deciding on priorities. So that prioritization exercise was very important. Start small. For example, with CalHabMap, we started with just 2 sites and we now have 9. And so in the FHAB strategy, we did that same exercise. So there's an entire chapter where we take all of the things that we designed and wanted to implement and developed kind of a phased approach to implement, to thinking very strategically and how you can start small and build on your successes. And so with that, I'll go ahead and stop, and I'd love to take any questions. And I already saw a few things kind of popping up in the chat here. So thanks for your time.
Jayme. Yeah, thanks, Jayme, for the presentation. And we just answered that question
Perfect.
Virtually. If there's one question in the room, I think we have time. Tabitha or Tricia, if you want to facilitate that question.
Okay. All right, Keith.
How did CalHabMap get its funding for that coordination?
Keith's question is, how did CalHabMap get their funding for that coordination?
Yeah, that's a great question. So we have 2 of the regional ocean observing systems that fund, together they fund the whole California coastline. So we have Southern California Ocean Observing System funding the lower 5 sites, and then the Central and Northern system funding the upper 4 northern sites.
Jayme, this is Meredith. I'm just going to add to that.
Sure.
I was on the original steering committee that started HabMap. So one of the things that's really interesting, I know this is going to come up during our breakout groups, is how do we fund some of this stuff, right? And with HabMap, what you heard Jayme say is we had a really clear vision of like what we wanted to do, what our objectives were, same thing for the FHAB strategy. And we basically started developing HabMap through a series of workshops. But really what we did was we kind of had kind of a strategy document and a vision. And once we had that, it's amazing how sometimes resources appear. So for example, one of the original goals of HabMap was to do an intercalibration study looking at different toxin methods and how those differ. And NOAA's ACT program, or the Alliance for Coastal Technologies, came in and did that for us. So we didn't even pay for that. Like, that was federal funding just showed up at our doorstep because we had an organized group and a plan and a vision. And so I'm really hoping that when we develop this strategy, we can kind of have that. And that way you kind of can shop it around and hopefully obtain sources. On the marine side, we have the benefit of having the federal funded ocean observing systems, and that definitely helps with a lot of the infrastructure. So that's maybe the piece we probably need to talk a little bit more about, but it's amazing once you have a vision, sometimes resources come there when you kind of.
Thanks, Meredith.
All right, I think we should go ahead and take our break and come back at 10:40. Good, okay.
Deck. All right. We can't hear you yet, Tricia.
Hey, Tricia, can you hear us?
I'm messaging someone in the room.
I am as well.
Okay. Will help a little bit. This is Karen Atkins from Central Valley Water Board. She's getting it started. Hopefully the audio is back up soon. Looks like they're paused.
Karen Atkins. I'm with the Central Valley Regional Water Quality Control Board, and I worked closely on this presentation, these projects that I'll be covering with Jenna Rindy over here at Fish and Wildlife. And today I'll be talking about existing HAB monitoring projects across California from a state agency kind of lens here. So first I'll be talking about the maps that Jenna and I created together in order to really put together some of the data that's being collected across the state and bring it all into one place so that we can leverage that information moving forward as we're trying to create this plan together. So using this spatially kind of compiled data here, we could, do lots of different things, including forecasts of drivers, implement controls, detect HABs that are already occurring. But really, again, we're trying to leverage existing data here. And so I'll be covering some of the drivers that are available in this table on the right here, and are also that table, which for drivers that we're interested in is also in the pre-workshop materials. So if you want to check that out in more detail. So the maps that we made particularly cover long-term monitoring efforts that relate to HABs. And so that means that there are no cyanotoxin maps because sure. Thanks for the tip there. Can you hear me better? Okay, great. So there's no cyanotoxin maps because we don't really have any long-term stably funded cyanotoxin data collection efforts. The maps were kind of compiled as a starting place. All this information was not in one location. So we are expecting that there are probably some projects that are missing. If you're connected with that project, please let us know and we'll be sure to include that in future iterations of these maps. And finally, these maps I'm going to kind of go through them quickly. So if you want to check them out in more detail, look at the pre-workshop materials where you can study them more closely. Next slide, please. So jumping right in, the first one is the HAB satellite analysis tool, which I know some other folks have covered already, but I'll cover it in a little bit more depth here. So you can see the area in black on the map is where the satellite imagery is covering in the delta, and the area in the gray is not being covered by the satellite tool. And that's just because of the size of the channels of those water bodies. The satellite is doing 300 by 300 meter pixels there. So you need quite a large channel to really have that resolution there. In addition, we are looking down from space, so we're not really going to get those benthic blooms that may be occurring. It's just looking at planktonic blooms. So this map that you see here has a circle in red on it, and that is clipped in Port Forebay, which you can also see in that picture with the pixels on the right. So this is displaying the cyanobacteria index, which is really the abundance of cyanobacteria, going all the way from kind of red, pink, where it's really high, down to what they're calling absent, which is just really background levels, doesn't mean there's no cyanobacteria at all. And so that's displaying just sort of the visual indicators there based on pigments of phycocyanin and chlorophyll there. So there is a new technical advisory committee, or TAC, that is being put on by SQUIRP. So talk to Jayme. If you are interested in joining that, they'll be covering some management questions as well as data quality. Just a little plug there. Next slide, please. Great. And the next map that we made is really looking at continuous data that has set installations there, and it's reading water quality data frequently and sending it into websites. Specifically, we got this data from CDEC, or the California Data Exchange Center. And these stations are stations that are measuring all of the things that I have listed on this slide. So pH, dissolved oxygen, electrical conductivity, temperature, and chlorophyll, so all of those. Moving on to the next slide. We also made one for hydrodynamic stations, again from CDEC, and those are collecting either just one or a couple of either flow velocity or river stage. So you can see those are pretty frequent throughout the Delta area as well. Moving on. So we also did some mapping of discrete monitoring stations, and the next maps that you'll see are all discrete monitoring examples. And these stations, you know, they don't have permanent infrastructure in one location, but there are folks who are going out and routinely sampling at those sites. That being said, the frequency, of course, varies depending on when, you know, sampling schedules for that particular location, as well. The length of the data set might vary depending on when folks started picking up that one site. So the source of this data is primarily from the Environmental Data Initiative's data portal, or EDI. And I have a link to that particular data set there that you can, hopefully the slides will be shared and people can investigate that more if they're interested. In addition to that, we emailed some principal investigators individually who we know had other projects and got their data. Thank you. So the first map that is of discrete monitoring stations is the Microcystis index scale map. This is a scale that you can just go out and visually observe how much microcystis based on these kind of categorizations you can see on the slide. And then you can rank them in 1 through 5, 1 being absent and 5 being a lot of cyanobacteria, a lot of microcystis in particular. And as you can see, that's something that's very commonly used throughout the Delta area because it's cheap and fast. The next slide. Another one that's pretty cheap to do is a Secchi depth. And that's really a clarity measure. You just drop your disc in and see how far you can see it. And that is done a little bit less frequently though. Next. We also have nutrient stations where folks are measuring nitrogen and phosphorus in various forms, as you can see on the right, that are being measured across the Delta. Next. And phytoplankton stations that are a little bit more rare. Those are mostly grab samples. Some are taken with Van Dorns at depth, and those are then analyzed for taxonomy down to genus in most cases, and then are also measured for biovolume. Next. And finally, we have weather stations. I think this is quite a non-exhaustive list, but it was what was on EDI. So that's sort of a starting place here. Moving on. Okay, so aside from all of these long-term monitoring stations that I covered, we also have lots of really important short-term studies like were pointed out previously. Here's some examples that I have here, but these are really important for answering the really pointed questions that aren't going to be answered with just routine monitoring and are typically funded through individual grant programs. And so it's really important to continue funding those individual grants that are funding these special studies. Next. In addition to that, there is incident response monitoring, which was also previously covered a little bit. As you heard, it's really managed by the FHAB program, which is what I'm a part of. These are typically where somebody reports an event to us or reports seeing a HAB. We go out and it's typically a one-time monitoring thing. It might even just be visual. It might include cyanotoxins. It depends on the case and the circumstances. And these are really important for public health protection, but they're also a really interesting way to see where aggregations of these HABs are occurring and then maybe point to maybe we need more monitoring in that location as well. So it is useful data in that way as well. Next. And we also have a partner monitoring program through FHAB. The goals there are really to improve human health protection, but also to find where we need to prioritize water body management and also to provide monitoring at these sites where we know HABs are occurring year after year. So the FHAB services that we provide to our partners include helping them create monitoring plans, doing training, not only on the basics of HABs, but also how to do some of these scientific methods in terms of sampling, and also to provide financial support and supplies whenever we can for those monitoring programs, and also to help them with outreach of whatever data they find to help it integrate into the public health protection, as well as getting it into the hands of scientists. So we're really trying to grow this program. And next slide, please. It kind of comes in a couple different facets. So first, we do the pre-holiday assessments, which depending on the year, usually about 3 times a year. And these are really trying to get the same locations a couple times during the summer and getting a baseline of monitoring at these sites. So it's really useful for public health, but it's also really useful as kind of a baseline of understanding what's happening at these sites with the help of community. In addition to that, we have sort of a longer term monitoring effort that we're trying to go and get folks to join that is at least seasonal routine monitoring, but we're hoping that they sign on for multiple years. And we're really interested in teaming up with you also. If anyone's interested, please come and talk to me. We have agency folks, we have local stakeholders, and we actually are going to hear from Spencer Fern right after me, who will be talking about his experience in this program. Next. And these are the sources in case folks want to look in more detail. And that's all for me. Thank you. And I think Spencer will now.
And can you hear me clearly? Okay.
Yes, we can hear you.
Okay. And so I just want to say thank you, Karen, for introducing me and also helping us with our partner monitoring with the harmful algal bloom problem in Stockton. My name is Spencer Fern, as was mentioned, and I am with Restore the Delta, and we have been monitoring HABs in Stockton. And can I get the next slide first? And so the question arises, why are we monitoring harmful algal blooms in Stockton, right? And what's like, obviously it all ties together with the Delta monitoring as a whole, but we're trying to help fill the important cyanotoxin monitoring data gap in the Stockton area. The reason why that's important is because the Stockton deltas are used as a recreational space for fishing, for boat launching, for regular just standing by the water, and there's many spots around Stockton where there's access, and then there's also not enough of knowledge of blooms in the areas, because then the amount of people that when we would go out and monitor that would ask us what's going on in the water and not understand what the blooms were was pretty high. So this lack of proper monitoring made it so that residents didn't know how bad these toxins were, like I was mentioning, and that's what we're trying to work towards at Restore the Delta. So like increase the understanding and hopefully bring more awareness to the problem, at least in our own backyard. And we're trying to make sure that we get these up-to-date toxin information so that we can also help to inform the public, whether that's through a social media campaign, which I'll kind of get into in a further slide, or rather just get it to the hands of scientists who could use the data to help inform the rest of the state in that set of mind. And eventually, one of our goals in the future is so that we can open a science monitoring program or a community science center, which could also be a monitoring society or monitoring facility, where I was looking for, but where we could focus on HABs issues as well as other water quality conditions, whether that's salinity, water temperature, flow, among nutrient loading, among different many things. But we just want to have the ability to self-monitor our areas so that we don't have to rely on at least the dates when we're able to go out and sample, so that we have more people looking at the problems where we can monitor harmful algal blooms in our area. If I can get the next, please. And so taking it back to what Karen was mentioning with the monitoring or the partner monitoring, we could not have gotten this off of the ground without their help. And so before we started collecting these samples, we had and running the tests on microcystins in the area, we needed a proper training and an idea of what the state agencies were looking for when we were collecting data. And Karen Atkins provided a training to our staff, our interns, me and myself, so that we could set up this monitoring so that when we were going out and collecting samples, we made sure we were collecting it the way that they were collecting it, so that it was a cohesive and necessary movement to making sure that we were all on the same page. And so this training we received made it very effective, because after that, it was easy to be able to explain it to my interns who either weren't able to make it or otherwise, but it was a method, and we continue to go through it continually. And that's something that can highlight how the Central Valley Regional Water Control Board was able to help us in setting this up. And so I guess the question of what sites were we testing, there were 7 sites total in Stockton. Those sites were McLeod Lake, Mormon Slough, Morelli Point, Smith Canal, the San Joaquin River at the Lewis Park, Buckley Cove, and Windmill Cove. And the tests we used were the Abraxas test strips for recreational use in microcystins, and they had a test limit of 10 micrograms per liter. And when those tests would reach their limit and couldn't get sent or couldn't be figured out, we would then send samples every month to UC Santa Cruz to get tested for liquid chromatography and mass spectrometry to get the idea of what species were in the waterways and so on and so forth. And the Abraxas test strips were mostly a weekly data pool. And if you can see the picture on the right side of the slide, that's the map we have our data set to. And eventually we'll have this on our website once our website gets nice and updated. But the tool itself, you can click on each site and it'll show you toxin levels, salinity, electroconductivity, water temperatures, et cetera, and it's all there, and eventually it'll be available, but we're still working on that. If I can get to the next one. And so kind of just a baseline of what we saw when we were monitoring was that blooms were most present in downtown Stockton, along the waterfront specifically. And for the whole month of August, and every week we tested at McLeod Lake specifically, which is also downtown Stockton, just for those not aware. They reached the limits of our tests at 10 micrograms per liter every week that month of August. And so out of the other 6 testing sites, there were only 3 locations that we did see blooming activity, which was at Mormon Slough, Morelli Park, and Smith Canal. And Smith Canal was actually the first place we saw a bloom in Stockton. At least it was like late May at that point in time. And the reason that's a big concern is that's one of those areas where people recreate. Smith Canal ends up in an area where it's American Legion Park, right next to a bunch of residential like homes. You've got people that would go to the park to fish, and they also go there to like set up barbecues. So that was one of those areas where a lot of people would come up to us because they'd be fishing, but obviously we'd tell them not to eat the fish if they didn't have to, and obviously most of them were just throwing their fish back anyways. But it was still kind of a concern to see that many people there with what was the most robust bloom we'd seen up until that point. But Windmill Cove, Buckley Cove, and San Joaquin River did not really show bloom activity, if at all. And I think the reason for that is because those areas we tested were a lot more of an open channel where there was a lot more flow and movement of water. But the one common trend, which I'm sure everybody in this room already knows, but the water temperatures were steadily increasing throughout the summer. And there were a lot of points where this data or this temperature rise was leading to oncological blooms. And a continued state we saw, at least towards the last 2 months of the summer, which was July and August. Those 2 months were primarily in the 80s in Fahrenheit for water temperatures. And that's well above the parameters needed for blooms to thrive. And it's obviously it's still preliminary data, but it appears that those water temperatures were the reasons why we saw blooms. And on top of the fact that the areas we were testing also didn't get much water flow. So the water was always stagnant in those areas and able to sit and collect heat energy. So at least that's about it. But can I get to the next slide? And so with the data we already collected and we're still working on sifting through it, our eyes kind of move forward to 2023 in the future and list what we're going to be able to do as we're sort of the delta for monitoring. And we're hoping to be able to monitor for many, many years into the future, but it always depends highly on funding and what we can secure which a few slides earlier, or a few people earlier were mentioning that it's always tough to be able to find ways to get funding to solve these or create monitoring programs. But I think we're set for this year, and with the help of Karen and the State Water Board with helping us set up our supplies for next year, it's easier to get done this year. And one of the things we do, as I mentioned in the previous slide, is that we run a social media campaign, whether that's on Facebook, Twitter, Instagram, or I think we're still working on TikTok right now, but that's a future issue. But we post these types of videos, and in the slide, I just took a screenshot of one of our videos that we put out when we were out in field testing. And our interns do a really good job of putting the footage we collect into a way where we can explain what we're doing. So we show the tests that we're running, we show the strip that we're reading when we're getting the examples, and then we're also explaining to the public why this could be dangerous. So it's one of the ways we're trying to work on public outreach, because that's always a big deal with what we're working with. But I guess this kind of ties back to, if we can get a community science center and get that tied to a college or some schools in the area, so that we can get the younger growing minds into the problems around Stockton, especially when a lot of people don't realize that there's a delta in Stockton, which is another funny issue too. But it's the idea that if we get public outreach, we get people in the know, and we have people working on the problems in Stockton, we could see this problem becoming a little less more mitigated in the future. And with that, I'm ready for the next slide. And that's if there's any questions, that's it for me.
Thank you, Spencer. Thank you, Karen, for your talk. In interest of time, we're going to move to the next presenter. But please, if you have any questions virtually, please put them in chat best as you can, because there's a team of us either direct messaging you, or we're going to email you to respond. Now we'd like to introduce Meredith Howard of the Central Valley Water Board on her talk. Thank you.
Thanks, Marisa. Can everyone hear me? Okay, good.
Yes.
Well, I'm going to talk about a HAB strategy that we developed and published earlier this year about really focused on HABs across the freshwater-to-marine continuum, or the land-sea interface. Next slide. Tricia mentioned this in her talk leading off the session, so I guess I'm going to wrap up with this. But what's really interesting is there's a lot of far-reaching effects of cyanotoxins that are affecting marine waters or the marine environment. And so the yellow boxes on this map show that really in every coastal area in the United States, we have documented impacts of cyanotoxins in the marine environment. So in order to kind of figure out how do we start to deal with this, it's really an emerging area of research that's come up nationally. A bunch of us got together and really tried to think about, well, how can we really monitor for this in a way that's going to promote effective management in the long term? Especially since what we're seeing now, there's a few papers that have come up more recently where we're really seeing cyanotoxins get transferred into the higher trophic levels, sharks, whales, dolphins, sea otters. So, it is ricocheting kind of up the marine food web. Next slide. So if we think about, well, what are all the sources of cyanotoxins potentially to the marine environment, there's quite a lot. And so this is a very conceptual, slide where you've got kind of rivers and streams, lakes and reservoirs, there's wetlands, there's estuaries, and, all of that can kind of flow into the marine environment. Next slide. So if you look at this as a conceptual kind of model of how we generally have monitoring set up, a lot of our monitoring is set up by water body type, mostly because a lot of water body managers have their jurisdiction and they monitor or they manage that jurisdiction, and there's not a lot of cohesion across these types of organizational or kind of local or state agency jurisdictions. The problem with this is that it's really ineffective when you think about how are we going to manage and mitigate HABs This system doesn't work. You have totally different sample collection and analysis protocols, so you can't really pull all the data together in a way that's cohesive that could give you a more regional picture. So what we set out to do was, Hans has a paper that came out in 2018, where he really talks conceptually about some kind of first order principles. So for example, if you try and do management in downstream water bodies, that's going to be really ineffective if you haven't dealt with the upstream headwaters first. So we tried to kind of build off that in our paper and really come up with some more actionable kind of recommendations for water quality managers. So next slide, so I'm going to kind of talk through those. So there's three main ones. The first one is that monitoring really needs to be coordinated and cohesive across hydrologically interconnected water bodies and across organizational or political boundaries and jurisdictions. The second one is that there really needs to be a combination of sample types and modalities included in monitoring programs, and that combination really needs to be decided based on the monitoring objectives. And then the third one is that that basically cyanotoxins should be routinely monitored in marine programs, but also, one thing that we see a lot is that there's multiple toxins being detected, whether you're in freshwater or estuarine or marine. Sometimes there's multiple cyanotoxins, sometimes there's combinations of cyanotoxins and marine algal toxins. And so kind of our third recommendation is that you really need a more comprehensive array of toxin analysis to really understand what's going on in your system. Just because you're not looking for it doesn't mean it's not there. Next slide. So I'm going to walk through each one of these recommendations. In our paper, we actually gave 1 to 2 case studies really illustrating why we came up with these recommendations. In the interest of time, I'm going to give you a very, very brief kind of some highlights. And so we'll start with the first one, which is the coordinated monitoring. It's interesting. So the Klamath Basin Monitoring Program is our case study example of this. And it's a really amazing program. It's one that I don't think we talk enough about in California. The Klamath Basin and the Klamath River and Estuarine system, it's over 400 kilometers long. It starts in southern Oregon and it goes through Northern California and it discharges into the Pacific Ocean. It's a pretty big basin. And so what they've managed to do here is they have a coordinated monitoring program that's implemented by a whole host of different groups, federal, state, and local agencies, tribal nations, dam operators, watershed groups. And what they've done is they've developed some standard operating procedures. So they are collecting samples consistently, they're analyzing them in a consistent manner so that they can collate all of that data regionally across the basin to provide this larger picture of what's happening throughout the whole system. Next slide. So what I'm going to show you today are several plots. They're all I call them bubble plots, but basically what you can see here on the right is on that Y-axis is all of the station locations, usually organized either from north to south, or in this case, inland to estuary. So the bottom 2 sites are the estuary sites. And then along the x-axis is usually time. And so what this particular plot is showing is data from 2017 from this monitoring program, and it's showing microcystin concentrations from water. And it's color-coded really based on whether or not there was toxin detected. So if it's an open circle, there was no toxin detected. But anything that's a colored circle means there was some level of detection. And the yellow, orange, and red indicate that it exceeded one of the California health thresholds. So what's important to notice about this is that what's been shown in this system, Tim Otten's done a lot of work on this, is in Copco and Iron Gate reservoirs, those are really the reservoirs that are the bloom incubators. And so he's done a lot with molecular methods to really look at that. And so once those start cranking out the toxin, you really start to see it percolate through the whole estuary system. So looking at this plot, as Copco and Iron Gate start having positive toxin detections, you start seeing it in some of the river sites. When they hit the peak concentrations, you see that toxin percolate all the way through and contaminate all the way through the entire river and estuary site, all the way into the estuary. And then as the toxin concentrations decrease in the late fall, you start to see those toxin concentrations decrease or be non-detect throughout the estuary system. And so this is really significant because this is a huge system. But it's really interesting the way that they have managed to pull a lot of different groups together and have this kind of level of data in a cohesive manner. Next slide. Okay, so recommendation 2 is to employ a combination of sample types and modalities. And I want to highlight this. You're going to hear me say this over and over and over again, because we get this question, well, how do you decide which ones? It really depends on your monitoring goals and objectives. You really need to have clear monitoring goals and objectives, because it could be different. In the previous example, like a lot of the work that Tim has done where he's looking at, where are blooms originating, you're going to use a lot of molecular methods there. But if you're wanting to see, if your monitoring question is more designed around what's the potential risk for the food web, maybe you don't need the molecular methods, but you really need to do shellfish or tissue. So what we recommend is a combination of sample types, that includes your water, passive samplers. There's lots of different types of passive samplers in California. We've done a lot of work with SPAT, or solid phase adsorption toxin tracking, because globally, SPAT has been the most widely used type of passive sampler for Hab toxins, but there's lots of types of passive samplers for lots of different analytes, shellfish or some kind of tissue samples, if present, cyanobacterial mats, and if relevant, molecular analysis. Next slide. So a really good example of this is some of the work that was published by Peacock et al. In 2018. There were multiple different types of toxins that they measured in San Francisco Bay. I'm just going to give you a highlight of one of them. So the top graphic is water samples. It's actually just the particulate fraction, and the bottom one is the SPAT samples. And again, the y-axis is oriented from kind of inland all the way kind of through the bay, and you can kind of see the map, but Sac River to South Bay. And so what's really distinctive here, this one is showing domoic acid. They also have similar plots for microcystins, but when you look at the water samples, there's a lot of open circles, meaning there was not toxin detected. Yet when you go in with the passive samplers, which are time integrative, so they're out there for a week, 2 weeks, and they're integrating toxin over time, you see that there's constant toxin detected and there's almost no open circles. So, this is a really good illustration of, depending on what you're looking at, you might get a different picture. And then next slide, if we add in the mussel sample, so they did a couple different studies were done looking at mussels in the bay, and what you can see is that for domoic acid, 100% of the mussels, they had detections of domoic acid. They also had detections of a whole host of other toxins that are both marine and cyanotoxins. So it's kind of interesting. What this is really showing is that which sample type you pick really matters, and you really need a combination. There's not one silver bullet. You can't just go out and measure one thing and think that you're going to get a comprehensive picture of what's happening in the water body you're looking at. Next slide. So, just to kind of sum up the bay, we really see both freshwater and marine toxins in the bay, which really just shows that there's this chronic system-wide exposure of toxins to the food web. And that combination of sampling measurements really provided that insight. And so we really have to rethink how we're doing monitoring in order to come up with effective management practices for HABs. Next slide. Okay, recommendation 3. I talked a little bit about this, but as we're looking for multiple toxins in some studies, not a lot, but we are finding them, whether that's multiple cyanotoxins, whether that's both marine algal toxins and cyanotoxins from a single sample, that's coming up more and more as we're looking for these things. And so it's really important to consider the fact that you want to measure multiple toxins. And there's a lot of studies from years ago where I think the focus was on microcystins a lot. We just thought we had a lot of microcystins. And I think in recent years, we're looking for more toxins and unfortunately finding them. And finding them at concentrations that potentially have health impacts. So one of our case study illustrations of this is We had a NOAA grant a few years ago, and we really wanted to look at like, well, what's really at kind of the marine outflows? What would we see if we went out and looked for both marine algal toxins and cyanotoxins? Would we detect both? Would we find them? So we did a year-long study in 2017. And we also calculated a toxin diversity index. And that's really just an index that shows like how many distinct toxin compounds were present. Next slide. So if we look at this, you know, same type of bubble plot where we have the Klamath estuary all the way down to the Tijuana estuary, so north to south in the state of California. And then this is just over time. And so there's a couple different pieces of information on this plot. The first is the color of the bubbles is the toxin diversity index. So warmer colors indicate more types of toxins. Cooler colors indicate less number of toxins. And then the size of the bubbles pertain to the sum toxin concentrations. So what you see immediately when you look at this is that you notice that there's a lot of warmer colors in the second half of the year. The other thing to notice is when you look at kind of the LA River northward, you have a lot of warmer colors in most of those systems. So there's actually more toxin diversity in kind of central and northern California, less so in Southern California. And what's also really interesting is, you know, when you have San Francisco Bay, Santa Cruz Wharf, LA River, those have very high toxin diversity, and those are constantly flowing and open systems. And so it's kind of interesting to just kind of see some of the differences where, you know, in Southern California, you have some of these estuaries that are only intermittently open. Some of the time they're closed. So there does seem to be some differences there. Certainly a lot of different hydrologic influences along the coast. Next slide. So if we just pull out a couple of the cyanotoxins, this is the same data set, but we're just looking at toxin concentration for anatoxin on the left and microcystin on the right. Really interesting. So anatoxin we detected throughout the entire coastline for the second half of the year, all the way through December, which was actually really just surprising. And then with microcystins, you know, you see it really in central and northern California, less so in Southern California. So it's just kind of interesting to see that when you start looking for these things, you really can find them. And there are definitely some distinct patterns here that we don't really understand fully. There's lots more to do on the research side, but definitely like a wide range of hydrologic influences here. Next slide. Okay, so if we go back to our conceptual model of kind of, this is really generally what we see throughout watersheds of, you know, just really different monitoring programs, not coordinated. We really need to transition from this in order to have effective management and mitigation to something that looks more like this. And so what this can look like is having, you know, very coordinated system, standard operating protocols that all the groups agree to, so that all of that data can be collated together and provide a more, you know, regional or watershed-wide system. And this is what's going to lead to effective management and mitigation strategies. It's a more cohesive, coordinated program across all of the hydrologically connected water bodies. Next slide. And ultimately, this is really the goal, is to just monitor one big interconnected system. If you've ever heard Jim Kern's talks, he loves to end with, you know, one estuary, one science. Same idea here. So that's kind of the goal. I think the obvious next question is, well, that's great. This is a really complicated system. How the heck are we going to implement this, right? That's a really good question. When we came up with this, I remember thinking like the Bay Delta system would be probably one of the more complicated systems to ever implement this in. But next slide, I do have some ideas on where we can start. You know, how do we start to implement this? So I think that the obvious first step is why we're here this week, which is really to start coordinating just within the Delta. So if you look at that dark green area, that's the legal Delta. And, you know, I think Karen and Jenna and others, if you look at that, there's an information packet of what Karen presented with all the different maps. I mean, that is a great start for figuring out how we start to coordinate, because there actually is quite a lot of data in the Delta. And so it's really just like, gee, we have all these pieces. How do we start to bring them together in a more cohesive manner? So if you haven't looked at that, there's some on the back table. I know Tricia had sent those out for those of you online. So that's kind of phase one. I think when we think about expanding that, we could expand into what I would call a phase 2, which is where we really start to try and coordinate with the Bay. And there's, similarly, a lot of efforts going on in the Bay. There's a lot of data collection. There's a lot of groups focused on HABs. So in theory, that should be something that we should kind of in phase 2 expand to try and coordinate both groups. And then phase 3 could really be coordinating with upstream monitoring programs, which we really don't think or talk about a lot, but there are some good examples. Next slide. There actually is a Sacramento watershed coordinated monitoring program that is between DWR and the Central Valley Water Board. And you can see from this map, there's quite a lot of stations up in that watershed, and they don't do HABs per se, but they do a lot of water quality indicators. And so you can already see where you could start to pull from that and try and figure out how you could coordinate that that program in with some of the programs in the Delta, and then ultimately. So next slide. I think with that, I will wrap up. I just want to acknowledge there's a lot of people that helped develop this strategy over the years. Jayme Smith was my really co-lead on this, and Ray Padella, Dave Karen, and Keith Lofton were some of the PIs that we worked really closely with. And then just a whole host of other folks that really contributed, the water boards, a couple of tribal representatives, PA, and then a lot of this work was funded by NOAA and the California Water Boards. That I will take questions if you have time.
Thank you, Meredith. Marisa, so I have a question back to the coordinating group. Do we have time for 1 or 2 questions? I know we went into the panel, which you all okayed. We have a question from the virtual end. All right, I don't hear anything from Tricia. I'm just going to ask it real quick for you. We have a question for you. Sorry, go ahead, Tricia.
Tricia's not mic'd, Marisa,
Okay.
so I'm telling you, Tricia is saying, yes, we can take a couple of questions. So maybe
Okay.
one virtual and one from the room.
All right, so virtual, we have a question. What vector or mechanism is likely most important in shuttling, quote, shuttling microcystin downstream into coastal waters and food webs? Is it transport of intact cells or something else?
Yeah, so I'm gonna tell you there's lots of things. You should look up Keith Bowman-Gregson's work. I actually didn't have time to show this slide, but I often do when I give this talk. A lot of the cyanobacterial mats that grow up in the rivers and streams kind of form these spires. They can break off. They tend to float because they're filled with bubbles. Those can be, transported downstream, and they can, basically set up a whole other bloom downstream. So look up Keith's papers because he talks about that. The other thing is there are a number of papers that have come out more recently that we cite in our paper, talking about how a lot of the hydroelectric dams, you would think that going through a dam would damage the cells, but actually there's been studies showing that it doesn't, and they can go through those dams just fine, come out the other end and still be growing and producing toxin. So that's kind of concerning, but interesting. And I'm trying to think what else. I think that's kind of it. I mean, there's lots of different sources. So when you think about sources and water flow, that's really transporting toxins downstream, assuming, and cells, quite frankly, I should say, not just toxins. I focus a lot on the toxins here, but there's plenty of papers, if you look up Tim's papers and Keith's, that show that, the cells really get transported as well. So even if you don't start with toxins, once those cells make it to a downstream water body, they can set up and start a whole new bloom that can produce toxins. Lots of fun mechanics with transport. Any questions from folks in the room? Go ahead, Dave.
Meredith, I really like the slides where you were combining the different toxins. And I was curious if you, because of those different toxins are going to have different toxic thresholds, did you grapple with the idea of normalizing them somehow by their LC50 or something, analogous to that, to try to put them in a similar reference frame?
So no, we didn't do that, because I didn't mention it today, but one of the things you'll see in a lot of my papers is that we have health thresholds for water quality criteria. In some cases, EPA has some of those
that are based on exposure to single toxins. And so what we're seeing more and more from our environmental samples, when we look for multiple toxins, oftentimes we find them. So it really calls into question, like, what's really the value then of those health thresholds that are based on exposure to a single toxin? So we didn't really go any further with the TDI because I felt like there were so many confounding things about, yeah, you have different types of toxicity there, but also just, what does it all mean? Because really what we're seeing is that a lot of the organisms in our systems are getting exposed to multiple toxins with different types of mechanisms, and they could be acting synergistically, and we really have no understanding of that. That's like a big, wide open kind of area of research that really needs better studied.
There it is.
Our panelists. All right, so we are going to switch into panels. So if I can have the in-room panelists, Meredith, Ted, and Spencer sit at the front, and then we have Veronica virtually, and she'll be joining us. Okay, so we should be coming in virtually, or our audio should be coming in. I hear myself anyway. So all these wonderful people have joined us for our panel today. I'm gonna let them introduce themselves. But what we'll do is we have one virtual panelist. So we'll ask her to go first when we ask questions. I have a couple of questions for them, and then we can also open it up to audience questions. We have this until about 12:15. And we will just walk the mic around to ask questions or have the panelists repeat them. So our opening question, and I'll go to Veronica online first. Can you tell us about your background or professional experience that will inform your contributions to the conversation? Just introduce yourself, please.
Absolutely. So good morning, everyone. My name is Veronica Burrell. I work here at Contra Costa Health Services for our Environmental Health Division. I am a supervisor, which oversaw our recreational health program, which is our umbrella over HAB here in Contra Costa. So just to kind of set it up a little bit for everyone, here in Contra Costa, we have a variety of water bodies, and back in 2016, HAB really came to the forefront of media advisories and public knowledge when quite a bit of harmful algal blooms was found in some of the water bodies in our counties, and particularly Discovery Bay and around Oakley, Antioch and such. And then from there, it's been pretty consistent. Every year we've had quite a number of large algal blooms in the water bodies of our county. So in terms of the environmental health perspective, we're part of a group together. We get weekly reports from the Regional Water Quality Board, as well as the East Bay Regional Park District. And they give us the weekly measurements, and then from there we send out the advisory signage and notices to the respective areas, depending on the current levels of the harmful algal blooms in the area. And apart from that, we field a lot of questions from the public, and we receive questions about other areas in their backyards that they're concerned of. And so, we forward them to the respective agency from there. But yeah, that's a general background as far as my perspective to the group.
And I'm just going to go down the line here, so Spencer.
Hi, everyone. My name is Spencer Fern. I'm the science coordinator with Restore the Delta, and we have been focusing on harmful algal blooms in the Stockton area for the past year and for hopefully for the next many years. A lot of my focus has been on the toxins and like being able to bring the data out to the actual rest of the state. So that's kind of where I'm at with it, and that's my perspective, at least from a local community and someone who's been born and raised in Stockton since I was born. But yeah, that's the
I'm Meredith Howard. I started studying HABs in undergrad and decided to go to grad school and did my entire PhD thesis on marine HABs. And then I did a postdoc and began working at the Southern California Coastal Water Research Project. At the time, they did not have a HAB research program, so they basically hired me to develop one. And I worked there for about 11 or 12 years. And about 4 years ago, I decided to kind of jump over onto more of the policy side. So I joined the water boards. I work at the Central Valley Water Board. So I kind of have that research background, but I'm now diving into the policy side of things as well.
Hi, my name is Ted Flynn. I work for the Department of Water Resources. I'm the supervisor and the principal investigator for the environmental monitoring program. So a lot of the data that's been presented today has been from the EMP. We've been collecting monitoring data on water quality, phytoplankton, zooplankton, and benthic invertebrates in the Delta since the 1970s. So some of the first detections of HABs were made by EMP scientists, Peggy mentioned earlier. And so I've been at DWR since 2018. My educational background, I have a PhD in geobiology. I've been studying the interaction between microorganisms and water quality. I started off studying groundwater actually, so fortunately there aren't a lot of HABs in groundwater. So, but I've been really, obviously I've seen it. I was a field scientist. I've seen the HABs in the Delta. I've been out there on the water, so I very strongly believe in the importance of both addressing this issue and also expanding and doing more for our monitoring programs to collect the data that we need to understand these issues.
Okay, thank you all very much. It's great to hear the different perspectives. We did have one additional panelist who's not able to join us. So I would like to go to the results of our Mentimeter from this morning. We can get those pulled up. Okay, so we provide some canned answers. These, of course, may not be all of the answers possible, but we asked folks what their desired outcomes of a coordinated monitoring strategy would be. Some of the major things that we see here are greater understanding of drivers for harmful algal blooms in the Delta, as well as more consistent data collection, which I think many presenters this morning also brought up. And then also better working relationships between monitoring groups. So keeping those in mind, I would like to go, maybe we can go to Veronica, see if you have a response. Do you think these are do you feel strongly that these are the highest priorities for HABs monitoring? Why or why not, do you think?
Yes, absolutely. So from my perspective, I got a lot of inquiries from the public and the media. And so one of their biggest asks is how often is data collected? When is it planned to be collected in the future? How is it disseminated? And often, as we all spoke about here, it's all dependent on the resources that we have, right? The funding that we have. And as it is in Contra Costa in 2016, we used to be funded by the county to do our own water sampling. And so we were able to assist with some of the data collection at the time and the water sampling. But since the funding has gone dry and we've had to scale back quite a bit of our involvement with HABs. So as it relates to the questions that I received from leadership, from people in public office, and from the public. Yeah, they just have a lot of questions as far as how often are water samples taken, how are they planned, which areas are selected to be sampled, and I think this shows that.
Thanks, Veronica. Yeah, so you're also touching on the consistency in data collection and funding piece as well, I think. Spencer, can I get your perspective?
Yeah, and I guess I'm kind of surprised that increased public awareness of HABs is on the lower, but I understand that there was only 3 to choose from. But I feel like the most important one is being able to incorporate this into the public knowledge, because at the end of the day, we're trying to solve where these toxins cause, and what's the purpose of why we're doing it, so that we can protect the public, right? So I feel like increasing awareness of the public, and especially where it's so that people understand just how bad these are, it's just kind of more of an important aspect of making sure that we're in the right state of mind and trying to fix these problems. But I do agree with most of the rest of the, honestly, the whole list was something I wanted to hit the selections on for the most part. But the greater understanding of HABs drivers is definitely a huge issue in the Delta, and something we can learn to focus on. And once we find what those drivers are, it becomes a lot easier to manage those drivers. Because if we know what's happening or what's causing, it's a simpler solution in that end. But that's kind of the way I see it.
So maybe I'll just build off what you said, Spencer, which is, I think there's no bad answer on the board. I think it's all important. If I put my water board hat on for a second, our mission at the water boards is really to protect and restore water quality. So from that specific perspective, I guess I'll say, really understanding the drivers, and I would say developing coordination and collaboration, as well as more consistent data, is going to really help us figure out how to manage HABs, and in the long run, how to improve water quality. So I guess that's my regulator hat. I would say also, just to add to this, I was on the steering committee that really developed and created HABmap, which is what Jayme talked about earlier, which is basically something similar that happened on the marine side. Back in about 2007, we had a workshop, or maybe 2008, where we pulled together all of the marine HAB researchers, end users. We had marine mammal agencies there, we had water agencies there, and there was really this need to start coordinating, especially on the coastal side, because what's in one place is eventually going to be in the next. It's just a matter of time before that happens. So just seeing how that coordination came together and how much has been accomplished through that effort is huge. Jayme talked about the fact that 15 years later, it's still in existence, it's still useful, it's still very relevant. Some of us were at the National HAB Symposium about a week ago, and there's actually now a national effort to coordinate regions, which is really awesome. And you can't have that unless you have regional coordination to build from. So I guess I've just seen great things come about from these types of coordination efforts. So I'll probably say that's probably my top pick from my perspective.
Yeah, this is Ted. I was thinking the same thing about, I guess surprised and not surprised about the better working relationship between agencies that was so high. I know personally, I've been on several multi-agency projects in the last couple of years since the drought began, and we had reports about the spread of HABs and scientists from all over state agencies, and I think I know it's been a challenge, and so maybe it's more of we've come really far, but we still have a long way to go, because we've written some work I'm really proud of that we put together from probably there's almost as many authors from as many different agencies as there are authors on these papers, and I think there's a sense of openness to sharing data, and people looking to try to just all work together to get to the right answer. So I think that's really exciting. But of course, it having also been on those projects, it can be a huge challenge to do that. It takes a huge amount of time and effort from staff and people putting other things in the back burner to get these things done. So if we can kind of remove those roadblocks, and definitely one of the challenges I think that needs to be talked about, as someone who's involved with the monitoring program like EMP, about the consistent data collection, and I think this is why HABs are such a big problem, is that we're talking about tiny ecosystems that exist on a scale that we don't see as human beings, right? When we see an invasive plant, we're seeing one plant that's not where it's supposed to be. When we're seeing a HAB, what that really is an ecosystem that has fundamentally changed, that's largely invisible to the naked eye, that we can't just see until it gets to the point where it starts producing toxins and all these things. So, some of the EMP scientists and I were talking recently about this. If you take a phytoplankton sample from 3 feet under the water and you compare that to the phytoplankton sample you take at the surface of the water at the same place at the same time, it will be completely different. And I've looked at samples from EMP where we'll do 1 meter under the water surface, and we'll do a surface tow, like a lot of work that Peggy's done. And the surface tow is almost exclusively potential HABs forming cyanobacteria. And the 1 meter, they're undetectable. You don't even see them 3 feet below that in the same water body. And, so when we talk about these things, and we talk about at a really high level, regional level, like understanding the macro and the micro scale to do these things for something like HABs is so critical. And that is, in my mind, also just one of the real challenges. So, the challenges are really across the board from a scientific perspective and management perspective and all these different things. So.
That's great. I appreciate all of you having different and really impactful answers to that. So another question that I wanted to get everyone's perspective on, and then we will turn it over to see if there's any room questions for the panel. So thinking about these different things, and I feel like Ted just kind of touched on this a little bit, is what are the major hurdles that you see facing HABs data collection and monitoring to make decisions regarding HABs in the Delta? I don't know, Veronica, if you want to provide a response online first.
Sure. So from the health department's perspective, to echo what everyone's been saying here, in terms of data collection, the funding has really been a large factor in how much we've been able to participate in HABs in the last recent years. We've been working with some of our groups within the county to collect more resources so we can be a little bit more proactive. Lately, we feel like we've been quite reactionary in terms of how the health department is messaging some of the public information out there. So in terms of the data collection and monitoring, also from the leadership and the public perspective, they would like to see a lot of forecasting, right? They want to know what happens when they're going to come to a trip in a year from now and a few weeks from now. So we do have to field a lot of those questions here from the health department. However, I would say the other perspective of it too is, as we're monitoring and providing information to the public, our job is to message it out to the public and to put signages out to inform them. And there's a lot of different dynamics within our county. There's private areas that we're not allowed to put out signages. So we're working with the groups within our county to do what we can to inform the public. So in terms of the health department's perspective, funding, and just being able to work within the means that we can, being that this is a voluntary guidance.
Really interesting. Do folks in the room want me to repeat the question again? Okay, so thanks, Veronica, for your response to that. What are the major hurdles that you see in your work facing HABs data collection and monitoring to make decisions regarding HABs in the Delta?
Some of the major hurdles I kind of went over in some of the slides that I was giving was that we run into the trouble of funding for sure. And I could see that being an issue with other non-governmental organizations or community-based organizations in other parts of California, where we would want there to be more involvement. You would want more data points, and then that way that's the kind of like the hurdle right there, is where we're trying to find ways to make it so that other people in the entirety of California, not even just Stockton or just the North Delta, but everywhere you can see blooms, whether that's just in California or nationwide, if you will. But the hurdle we see, at least with monitor or making decisions in that, is that there is not enough data. And one of the things I see in many reports is that there's not enough data for what the actual problem with blooms could be in the future years, knowing that climate change is accelerating the rate in which we see blooms each and every year. But the one thing I could say is that whether we continue or continue or not, we need to find a way to make it so that monitoring can be a lot easier, and whether that's involving community in the way of citizen science and just getting people to find blooms. And obviously it feels like I'm going to be a broken record by saying keeping the public informed. The more people you have that can see blooms, the more people that can understand what they are, it'd be a lot easier to monitor these blooms as they are happening. And so that's what I kind of see as the hurdle to get over, is just public knowledge and funding are the two things I think are the most important, at least from my community-based organization.
Well, I guess from my perspective, if you think back to Karen's talk, where there was, a lot of work that she and Jenna and others in the room put together to really just, where do we have data, right? There's actually a lot of data in the Delta. So I don't think that the data collection piece is our biggest challenge. I think the biggest challenge stems from a couple of things. One is coordination amongst the different groups. So they actually color coordinated their maps based on which agency is collecting that data. And I think what you see from like some of Ted's publications and some of my publications is there's a lot of coordination when we do these kind of individual things. There's not any kind of formalized either, steering committee, task group, some kind of whatever you want to call it, advisory committee. There's no kind of formalized group in the Delta. So I guess one thing I'm hoping that comes out of this workshop is that there is some movement towards having some kind of core group that can, really think through how are we as a group going to implement this strategy. And that's kind of what we did with HABMAP. We came up with a steering committee that had different representations on it, similar to kind of what Jayme showed with the pie chart of the TAC that developed the FHAB strategy for HABMAP. It was really similar. We really thought through, like, how do we have good representation on a committee to make sure lots of different perspectives are heard, and to think through, how can we start implementing this strategy across all these different groups. So I think that would be, for me, the number one. I think the second one is when you think about funding, at least from what we've seen in the past with some of these other efforts that have been successful, is that once you start coordinating and you have a plan and a vision, you might not get all the funding you want, because of course we always want more funding, we always want more data, but you do tend to get what you need, I think, at least at a bare minimum. And so it's been really interesting to see how that developed, because that was also the number one thing we heard. And we did a series of workshops to get HABMAP off the ground. How the heck are you guys going to fund this? And it's like, well, it's interesting. Like, there was a lot of resources that came to bear. And once you have an organized group then we started writing that into our proposals, and it's amazing how easy it was to get funding when you say, well, we've got this whole regional group that's already coordinated, we have a steering committee, this is our vision. It became really easy to even obtain like grant funding as well, so.
Yeah, I think kind of following up on that, I think one of the biggest hurdles is a lot of our efforts have been, when it comes to funding, there aren't a lot of clear mandates to resource agencies and other places like you will do this monitoring because, and so what happens is we tend to get a lot of reactive monitoring. Oh, it's a drought. Oh, HABs are getting worse. Let's do all this stuff. And then when we go to analyze the data, we don't have that data because we weren't collecting it when we weren't paying attention. And so one of, I think, the values of, a long-term monitoring data set, and of course I'm biased, I'm going to look at, ENP's data set, right? We go out every single month. We've gone out every month since 1975 to collect that data. So when we want to say, well, how has this changed over time? We have that record, right? We don't have that for HABs. Part of it just, as Peggy pointed out, it wasn't a problem as much 30 years ago, or when these things were written. But to kind of have those mandates so that the resource agencies can then go to their stakeholders and say, hey, look, we don't have a choice. We're going to do this. A lot of the work that has been done, I mean, a lot of the work that Peggy was showing is stuff that, she mentioned, these are special studies. These are things that people like Peggy and others have to, keep tomorrow. Like these are people, coming and saying, this is the problem. Let's do this. Okay, let's study that for 3 years. And then it ends. And then, so we might have really 3 years of good data, but maybe those 3 years of data are all critically dry years. And so, okay, we know what critically dry years, what do we know what wet years look like? All these things, and we've all seen how dynamic a place the Delta is, and it changes so much from year to year, depending on so many different factors, that that's a huge issue. And so I would like to see more of those clear mandates that make it easier for people who run these monitoring programs. That I think we as resource agencies, we're good at that. We are good at collecting data dedicated over time with, really, really strong scientists. Because that's the other thing, that I had here too is, and I kind of alluded to it before, like this is not something that's going to be solved by taking some extra water samples when you're out on the water. These are things that require really strong technical knowledge. As you were showing how, the training that your citizen science, people, look at iNaturalist and you think, oh, citizen science is great. Just people have cameras, they take a picture of invasive species and then you're good to go. But, for something like HABs monitoring, citizen science, you can't just give them a cup and say, hey, go grab some water and bring it back to this place. It requires training and that costs money and all these things. So I think those are really things. And the other thing I wanted to say that Spencer brought up too is climate change. The things that are driving HABs are inextricably linked to that. And this is something that happens globally. This is a problem everywhere. This is not just a California problem. And so we can be as on the ball and do as much as we want to, but we exist on an interconnected planet. And so as temperatures continue to increase, which we all know leads to more HABs, these things, droughts become worse, more prolonged, we can do everything we want and we still are going to face more challenges. So we have to be prepared for that. And I think that's to me maybe the biggest challenge of all.
So true. It's not just about the Delta or the estuary or the watershed, it's about the whole globe and all the influences that we have to think about when we're trying to develop this type of monitoring. So I'm gonna take a pause in my questions and see if there's any in-room questions. Tabitha is online, seeing if there's any questions in the chat to see if anyone would like to ask the panel a question. Yeah, Shauna Kuya.
That poll is very, very interesting. A little distracted by the results. I was like Spencer, a little surprised about public health, especially since there's a lot of presentations for mentioning public health a lot. Yeah, the poll did not reflect that. So that was interesting to note. Also, you noted a lot of things about factors that are drivers. Yes, that was the top poll for more about it. There's a lot of things. So it would be good for the science program to try the those things that could be done. So that's my kind of question to you. Will you be exploring that a little bit more, the poll with these panel, these individual parts of the workshop and breakout groups? You'll be exploring that kind of question. And then as another side question for like Spencer and for Veronica, for your program, how much did it cost? I mean, the budget, was it somewhat consistent over years, or was it really dynamic, or was it just increasing every year? So I know those are two different questions.
Yeah. Okay, so there's two questions. One question was for me, and it was about how, well, for us, pretty much as a planning team developing this draft strategy, how surprising the results from the Mentimeter were, because it seemed like a lot of our talks and conversation were about like highlighting the need for public health, the conversation around public health. And then the other part was that we talk a lot about how we do have a lot of data, but the response on the Mentimeter was greatly around how we need to have increased data collection and consistency. So I captured that correctly. Okay. So my response to that is that is a huge part of what we're trying to do with this workshop. We're trying to get that kind of information because these are things, that we're seeing from our side. And like, we think that we have a lot of data collected, but at the same time, we know that that data is collected in a manner in which we may not be directly translatable to some kind of management decision. Like maybe that connection is not there. And that's maybe a low-hanging fruit that we could try to take advantage of through the development of this draft strategy and through the work that we do here at this workshop. So that is something that I think we're really hoping to work on and digest and get more information from the different audience members of this workshop to bring into our draft strategy. And the second question was about funding for both Veronica and Spencer. So Spencer, I don't know, maybe you want to kick that off.
So funding, at least for what it looked like this past year versus next year. The thing I can say that was most expensive was the test kits we used, which were the Abraxas test strips, and needing to get them for weekly monitoring. Initially when we were planning this out, Karen was saying that if we take it every other week, if it was almost like on an every other week basis, it would have been fine because of like cost constraints, but we decided to do it every week, which kind of drove the price up a bit. So like doubling the price over a testing period because it'd be every week. The other aspect of it, which we didn't pay out of pocket for this one, was the samples that were sent out to UC Santa Cruz. And I know those can be really pricey, at least the liquid chromatography and mass spectrometry. Those tests are the ones that are expensive and not really something you can get on a consistent basis, which is all we could do was those samples that we had from our 7 sites. We'd sent them out every month, and it was only for about 4 or 5 months. So that really limits what we can test, at least for the large scale, because again, the tests that we had for Abraxas were a limit of 10 micrograms per liter, which is fine for getting a baseline for the data in the area, which is just so that we have something to show that, okay, these toxins are in the water and this is when we saw them. But the prices, at least in like terms of budgeting, we were able to manage it this year, and I believe we'll be able to manage it this coming year too. But I'm not entirely sure if the prices go up dramatically on a year-to-year basis, because this was the first year on a pilot program for it this year. But yeah.
Thanks, Spencer. So Veronica, the question was, how did you get funding to do the testing that you have been able to do?
Right. So from our perspective, back in 2016, we were able to acquire some funding together from the Board of Supervisors. And around that time, obviously, 6 years ago, it was actually in respective to all our other programs, not too much, but most of our activities on the area was reactionary, right? We were taking water samples after some complaints were received from the public. So to put some actual numbers into it, back in 2016, it was about $18,000 to $20,000 for our program. Since then, we haven't been as involved as we'd like to be. So our involvement has definitely decreased. To answer your initial question, it is dynamic, and as Spencer said, it really depends on how often we're going to be taking tests. If we want to be proactive and take it, before the season, weekly, which bodies of waters within the county do we want to test it? Absolutely, that's all going to be part of the price tag there, versus the very minimal, as we receive complaints, that's when we'll be out there doing collection or providing the public with signages and such. So it's dynamic. It depends on absolutely, the season, how it's working out this year, and then also on the needs of our county, right? Whether it's by the upper leadership or public engagement. And I think that's a big one. Once the public is more involved, I believe the funding will have to flow with it.
So in both circumstances, it seems fairly impermanent, a little bit more reactionary, not proactive. Are there any questions in the chat?
Yes, there's a question. Tabitha, did you want to read it?
You can read it because you're
Okay.
better.
Okay. Sue is asking, kind of following up on the earlier questions to the panel, what should be the priorities for Delta HAB monitoring program? Example, is it public health? Is it toxin characterization? And what tools, for example, macro versus micro scale?
Let's see, Meredith, do you have an answer?
Yeah, so I think it's really important to consider who the users are of this information and ask them what their main goals, needs, objectives are. Because I think there's a lot of different answers to that question. And definitely when we did the HAB map round, we had a lot of what we called end users at the table. It's basically same thing as saying state agencies. We had marine mammal agencies that were dealing with the rescue end of that on the marine side. We had water quality managers at the table. And so I think, particularly in the Delta, there are a lot of different groups and agencies involved in HABs, in some aspect of HABs. So I think that's a really good question to be asking a group, like a larger group of people that have a lot of different perspectives, and then you kind of pull those perspectives together and narrow that down to like a set of goals and objectives, and then you kind of work from that.
Yeah, no, I agree. I mean, I think that it's really going to depend on the user data. So, for example, like the priority for monitoring for, say, RTD is going to be hugely different than the priority monitoring for DWR, right? Because we have vastly different stakeholders, and ultimately we're all the same stakeholders because we all care about the Delta, but at the same time, like people who live in Stockton who go to a Pacific Park really want to know, is this place safe to swim in? Can I, let my dog jump in this pond and something like that? But if a huge statewide agency like DWR, like, be monitoring every pond in this, we're responsible for the whole state, so it's really going to depend. But, someone like us that is responsible for monitoring across the Delta, we are in a good position to be looking at, say, like, ecological drivers and understanding these, mechanisms that might be leading to certain types of blooms, or why you're getting toxic blooms or non-toxic blooms, or, what are the hydrological drivers that are leading to HABs in certain areas. Those are types of things maybe we can do really well. And so I think getting us all together and getting in the same room and trying to figure out who's doing what and how we can inform each other is really critical, and it's not, I think we've all been looking forward to this workshop for a long time, and it's not going to be a question of us all just getting in the same room and saying, okay, let's figure it out. Okay, good, we're done. They'll talk to you in 10 years or something. This is an ongoing conversation, and it's something that is, we're going to have to, keep collaborating because things change it's a dynamic thing, and, something that, like this understanding that some of these really small sloughs that are kind of maybe to someone who's looking at the Delta from a 10,000 foot view might think of as very minor, unimportant. Well, those might turn out to be where, seed beds for Microcystis, where it's growing because it gets warmer there faster, and then they're flowing out to the rest of the Delta. So I think having those, channels of communication is going to be super critical. And that's going to inform the data that's collected.
And if I can add something real quick, one of the things that I think is interesting, and Ted mentioned it too, is that the knowing which blooms are toxic or not toxic is, and I can obviously only speak for myself, but like for the community I'm in from, and obviously I agree with Meredith that it's something that many different people have a different answer to. So I guess I'll just answer what I think is interesting. Is if we could determine what bloom is and isn't toxic, I think that would be a huge flag for understanding what blooms are toxic. Or obviously, like we could see it in real time. We could see it in the water. We could see why these blooms have toxins and why they don't. But the one thing I could say is it's like obviously from Stockton, we're not focused really too much on the drinking water aspect, because where our blooms show up is very much in a recreational area. So we know that at least areas, at least in Clear Lake, that becomes a drinking water problem. And other parts of the United States, obviously there's different issues and different mitigation measures. One of the interesting things I heard in a previous talk with some of my colleagues from UNC was that they mentioned that over there, their mitigation measures is not being able to, or not using their water to water their lawns as much, which we don't really see too much in California because of our drought. So obviously where you are, the mitigation measures and understanding on a macro or micro scale what you need to do to solve the problem is always going to be different. So I think that's important to get other people into the room to have this conversation about how we can mitigate the issue.
Veronica, do you want to add anything before we move on?
Just as simple, I'll just echo what Meredith said. It really depends on the end user. And as far as the health department's perspective, public health would absolutely be the priority, along with the environmental impacts, because those are the people that we're informing. So that's how we would be using the data mostly.
Thanks. Yeah, I gotta say, a lot of this conversation is really helpful to lead into our breakout discussions this afternoon and tomorrow. There's a lot of parallels that I think we will all get to talk about as in small groups. So very exciting. I will see if there's another question. Yes.
One thing I haven't heard too much of today, a little bit, is dynamics between aquatic plants and cyanobacteria. And it seems like, there's an interaction there, and they're competing for light and nutrients and all sorts of good things in the Delta. And so curious about the interplay of that and how that affects what we think about for monitoring.
Yeah, and I think that's also a great question for tomorrow. But Ted, do you have a response to that?
Yeah, forgive me if I'm getting a little out of my element, but so if someone else knows more about aquatic plants than I do, then please feel free to jump in. I know that some of the say biogeochemical aspects that we've been looking for as effective ways to monitor for things like HABs can be difficult to disambiguate from, say, large presence of the submerged aquatic vegetation, something like that. So for example, in the recent we call it the HABs Weeds report that DWR led last year. We were looking at the harmful algal bloom in Frank's tract. We were looking at the increase in dissolved oxygen and the increase in pH over time, and they both got very, very high. And now those two things, if you had a big increase, we have lots of water quality signs that we have out, you can use those things to see like, oh, hey, wow, look, pH and the DO are shooting up in this area. Maybe we have a HAB there. We should send out some additional monitoring, things like that. Well, those can also lead to, those are the same factors you would get if you had a lot of plant growth, right? The photosynthesis is going to do the same thing. And so that's why I think having, really kind of these multivariate ways of looking at harmful algal blooms. For example, we used data from the Sentinel-3 satellite, which actually has a special, measures the spectrum specific to, the blue pigment in blue-green algae, right? Phycocyanin. And so it can actually detect not just total chlorophyll, which you might get from plants or other organisms, but you can actually see where those blooms are occurring from a satellite imagery. And so I'm not super familiar with, if you're having an expanse of plants, how that might maybe either crowd out a bloom or lead to more. I'm not really sure about that exact interaction. I'm not sure if that is known or not, but I do know that there's certainly some kind of interaction there. But yeah, sorry if that's not a great answer. that's as much as I got it.
Yeah, go ahead, Peggy.
I have a thought.
One of the things that we monitor for, of course, is to get rid of the blooms. In the end, that's got to be our goal. So I want to ask the panel, from your perspective, which variables would you focus on to manage the bloom?
It's a huge question. Anyone want to kick us off?
Okay.
I think the biggest factors for the delta that we should really focus in on are one, water flow, right? Nutrients, you talked about, temperature. I mean, those are the three big ones, right? And there are some management buttons or knobs we can turn on those, but at the same time, there are so many different, water issues. We've got drought issues. So sometimes with water flow, there's like other reasons why you're going to make decisions on water flow that really have nothing to do with HABs or, so it's complicated, right? When you have this type of complex ecosystem where there's multiple water quality and water flow issues and many different management decisions being made in the same water body, it's complicated. But from my perspective, so it's hard. I don't think it's an easy, I don't think it's easy. But I think if we focus on kind of those are the three main ones where we seem to have at least some level of a knob to turn a little bit one way or the other. There's other things like climate change where, that doesn't feel like there's any management knob to that, which isn't necessarily true, but it's such a global issue. It just feels really beyond any state or local agency in the Delta. Whereas some of the others, there might be a little bit of wiggle room there where maybe we can't get rid of HABs, but maybe we could improve HABs if we turn the knob slightly this way, which isn't all the way this way or all the way that way, but maybe if we just tweak it a little, we could see some like measurable improvements. And I think it's a really important question. I mean, I think when you look at HAB mitigation, there is no silver bullet for HAB mitigation. I think going out and figuring out like what is the bar we're going to set. And I don't think that the bar is we're going to get rid of HABs and have no toxins. I think that's an unrealistic bar to set as our goal. I think our goal is, can we see measurable improvements in water quality? So maybe we don't have, toxins that are exceeding the health thresholds for 2 to 3 months of the year. Maybe we narrow that down to a few weeks to a month of the year. That to me is measurable improvement. I think that's a good goal. I think a goal beyond that where we really are talking about, either no HABs, no blooms, or no toxins. I think that's kind of unrealistic is the sad truth. Sorry to be negative Nancy, but I don't know, Peggy, I'd love to hear your perspective on that too. Maybe I can just turn it around to you and talk to somebody else. hear your perspective.
I just kind of want to echo on the flow. I feel like Peggy makes a good point about flow, and I've always kind of theorized that if we could introduce freshwater flow into a system, it kind of solves all of the problems of nutrients and water temperature, well, aside from what climate change causes. But if you think about it in this perspective, most of where Stockton, where we've seen blooms, are areas where water goes and stays, where it stops. Areas where, I mean, obviously the problem with water is it's got a high specific heat capacity. So once it holds its heat, it's not going to really get rid of it too easily. So if water's sitting still in an area where nutrients can find a way to stop, you almost feel like adding flow into these areas or making a way so you can reconnect them to other parts of the channel makes it so that these areas aren't sitting still and increasing their temperature. Nutrients aren't able to load and sit in one spot. And then obviously blooms themselves aren't going to be as productive if the water is continuously moving. So I personally think flow is the most important aspect of it and could find a way to help solve the problem. But it is so easy to say that you just add flow to a thing and it becomes a mitigation, or it becomes a problem of how do we introduce these flows. And that's kind of where I've always been like, how do we introduce more flows? But that's where I stand.
Thank you. So we're a little bit over time, but I want to give one final opportunity for any closing thoughts from any of the panelists before we break. Okay, Veronica, do you have any closing? Okay, she's good. All right. I know there are some remaining questions in the chat as well, so we will log those as well, but I want to give everyone some time to go get lunch. So thank you, everyone. We are going to reconvene at 1:30 and we are going to go into small groups for the afternoon to have some greater discussions there. So let's. We probably only need to open 6 online rooms. So thank you to Beck and Eric for doing that. I'm going to do a quick little orientation. I'm going to start with virtual, and then I'm going to come to all of you in the room. So this afternoon, we're going to be doing virtual and in-person breakout groups. For the virtual breakout groups, we have mural boards that the facilitators of each room already have access to. Facilitators for your rooms. When you get into your breakout room, please copy the link that you were provided into the chat, and so that all of the participants in the room have access to the mural board that you are hosting. And we will have people coming through the rooms to make sure that the link is right, but please, if you're a facilitator, remember to do that. Quickly, people who are not going to facilitate this afternoon, who I had asked to facilitate, are Scott, Ben, and Jill. You guys no longer need to facilitate. Again, Scott Navarro, Ben Geske, and Jill Harris, you guys are not facilitating anymore. Everyone else, if I had you as a facilitator for today, please, when you get into your room, copy the link that you were provided into the chat for all of the participants in your room. Okay. So the facilitators of these rooms, they're really going to be, this is for both in-person and online. The facilitators are really just there to kind of move the conversation along, to get people to answer the different questions. But really we want to get the perspective of all of the people that are attending both virtually and in the room. We really need you to provide your information, your experiences, thoughts, and feedback to the questions. So when you're reading these questions, think about how you would answer this question with the resources available to you. If you feel like this is, if you're like, oh, I wouldn't know how to answer this question, then I think that is also important information to capture. So for online, once you get to the end, please help your facilitator refine the predominant conversation in the room so that we can have like a 2 to 3 minute report out when we come back. And the mural boards online, it's really easily laid out. You just like move through the different groups and the different areas, and then you will write out your report out at the end. Your facilitator can help you with that. So I think with that, Beck,
/ Eric, I think we're ready to send folks in this virtual room into their breakout rooms.
Okay, sounds good.
Thank you. And let me know if you have any questions. Okay, folks in the room, what we're going to do is we have just 3 groups. We all. Okay. So I'm going to have people gather around these different questions. You're just going to be targeted on one question, and then we have facilitators at each question. So Ted, you're going to be all the way over here. And then Spencer, you're in the middle. And Jenna, you're on the end. These are our in-room facilitators. So they're going to help us and like walk through the questions and think about what you want to answer, how you want to answer. And then at the end, you can help your facilitator come up with a response for the 2 to 3 minute report out. I think how we'll do this, because we have fairly a small group, let's just count off 1, 2, 3, and then if you have 1, 2, or 3, please go to that's questions 1, 2, and 3. So 2, 3, 1, 2, sorry.
3, 1.
Oh, not you. Sorry. And then, question 1, question 2, and question 3. Like I say, if you feel like you want to answer the questions that are in different groups, you're welcome to get up and walk over to different groups. There are stickies and there's pens, and so you can walk over, grab a pad of some stickies, write your thoughts out as a response to the question, and then put your sticky on there. And then your facilitator kind of will move you along. To start out, you'll just group up together, kind of introduce yourself, and then for both in-person and virtual groups. So I'm going to go question by question. There are 3 different sets of questions. I think I'm going to start. Looks like there's furious typing happening. I'm going to start with question 3, and then we'll go backwards. So I'll start with in-person. Jenna, if you're ready. Is it you or someone else in your group? Okay, I'm going to walk this over to you. If you could report out for your group.
So our overarching question was, how can HABS monitoring be combined with public health incident response to create a cohesive HAB strategy? And then there were some like sub-questions about how do we maintain communication before, during, and after blooms? How can we improve? And how can we coordinate more broadly with our estuary-wide partners? And so our like 3 take-home away things was, the first one is kind of, it could be its own thing. It was having communication plan where, and having like a team. I think this is kind of what like Meredith was talking about earlier, is like you really need to have, or in an ideal world, have a team that meets at a certain interval. We already have those existing relationships formed, and have a point of contact from each agency to just communicate faster. And so when a bloom happens, you're not trying to figure out, wait, who do I contact? What's this? So, but then there's not caveats, but things you need to consider, like the geographic scale, where to focus, protocols, and really just for the different stakeholders that have members on the team is have an investment into it. That was kind of a long one. I'll make the other one shorter. The other 2 takeaways was
This one was really interesting, was having social science involved with taking surveys of the local community to understand the existing behaviors in the area and see what we can learn from that. And then the last kind of takeaway was having QA/QC data really available to be intercompared to make decisions. But what we really need to understand is what data is needed to make certain kinds of decisions. So it's kind of like chicken and the egg kind of thing. We need data, but then we also need to know what kind of data is most useful, I guess, and how to prioritize the timing of those results.
Thank you. Okay, and then I want to do the same question online. So can we go to the question 3A group, which was Sylvia / Chris / Jill?
Hi. I can do the report. So in our case, in our group, we came up with like a summary for each of them. 4 questions. And the first one, how can monitoring be combined with public health incident responses? Our takeout sentence was that measuring, monitoring hub abundance from one side, and also in the same time toxins at particular stations could provide this link between just hubs monitoring and public health incident responses. And also we discuss a lot of ways of lines of communication before, during, and after, and how to improve them. Basically, we came up with like the comment that a centralized website or a database that it's easy to access and navigate and it doesn't crash would be important in these lines of communication before, during, and after events. And also using different sources to target different preferences of people and ages, like some people prefer use smartphones or maybe text or email, so different apps or maps. So depending on the people, the preference would be different. So it would be good to encompass a wide different type of media source. To improve, there were like different areas to improve. We kind of like categorize between perhaps people that already know that the hub problem exists. So for these people, not only these media outlets like text or emails or apps, also some people just want to know if it's safe to fish or swim or not. Forget about emails or websites. And then for people that don't know perhaps about hubs, education outreach would be a very important improvement, like include hubs, the hubs topic in curricula at schools, for example. Then for how can we use this effort to coordinate more broadly with the Statewide partners? We kind of collectively didn't understand very much the purpose of what we refer to effort, but we kind of conclude that perhaps having just a centralized web page that everybody has its own website or web page or database. So perhaps some effort to have everything centralized with all different partners would be useful.
Hey, thank you. All right, we're gonna go to question 2 in the room. That's Spencer.
So in our group with our questions, the questions were, at least I'll start off from the top and then I'll just kind of go through what each question was. But the first question is, what hurdles to HABs monitoring do you experience and how can those hurdles be overcome? And one thing I'll note before I answer this one is that a lot of the questions, or a lot of the answers kind of tie together with the rest of the questions, so it's a lot of repeating. But the first issue that came to mind and was in all three of these, believe it or not, was the money is an issue overall for everything, and funding essentially for finding ways to increase monitoring and incidents response and so on and so forth. But another issue that we've seen is that there are multiple groups that are looking into HABs monitoring, and there isn't exactly a cohesive planet map monitoring strategy, and that's the goal would be to have something along those lines. And it was mentioned in some of our previous presentations today about needing a cohesive monitoring strategy that way. So when we're all collecting data, we're collecting data for the same standpoint. And I also mentioned it earlier was that the lack of money means there's a lack of manpower for incidents response. So it becomes an issue of what can be responded to and in what ways that they can be responded to. But the next question, which kind of ties in, is what support do you need to coordinate new data collection efforts? And kind of like going back to the cohesive strategy, we also mentioned things about citizen science and making sure that they're getting trained the same way in an effort to also increase what citizens can do when on the water, aside from just taking pictures, but whether they're collecting water samples and taking them out to scientists in the field. It also is something that we wanted to see. And another thing that also ties into money, of course, is that there is a lack of staff for these types of issues and needing to hire more staff for whether that's just monitoring or being able to sift through the data. And I know that was another thing that was important, but at least that was for the question 2, and those 2 questions kind of tied together. But the last question was, how can new monitoring be improved or changed? And this kind of goes on to factor in different types of different parameters, different sites. But one of the ones we talked about in our group was improving the tools. So one of the conversations were centered around maybe making a new monitor that can search for toxins in the water, essentially, but also not at the cost for making it so that other areas that might not be as monitored don't get monitored. So it's important to have the tools in place, but not at the expense of not monitoring in other spots that can't have access to these types of tools. And bringing the right people into contact. So kind of ties back to the citizen science, but making sure that people who are going out there are knowledgeable, whether those are fishermen, captains, and that was pretty much it for this one.
Thank you very much, Spencer. Okay, so we had 2 groups online that also tackled question 2. So I'm going to go to the room Q2A, which Henry was facilitating.
Hi, yeah, so I think I'm reporting out for that group, and so we had the same questions. We had a lot of the same kind of sentiments as the in-person group. I think we ended up drawing essentially a schematic of this idea that funding is probably the biggest hurdle. Funding dictates the programmatic approaches that are available to you, because if you think about HABs, they affect a lot of different uses, and there's different stakeholders that maybe have different needs and wants, and a monitoring there could be, several different types of monitoring programs depending on the question you want to address. And some questions are harder to answer, like driver studies versus kind of public health monitoring, where you can get away with just monitoring toxin, for example. So funding kind of dictates the programmatic approaches that you could maybe use. And then public awareness is a part of that circle, where public awareness informs funding. And it also is informed by the types of monitoring that you're able to do. So for example, public health monitoring and being able to post signs. So we tried to come up with a 2-sentence as the charge led to address all three of those questions, like kind of a 2-sentence phrase. I think we ended up with 3 sentences, but essentially HABs have a lot of different impacts on a lot of different stakeholders with different needs. There's not much funding, and HABs is a complicated issue. So developing coordinated methods and sustained funding is the most important and biggest issue facing monitoring. So I think unless the group wants to jump in, I think that Spencer had touched on a lot of the other issues we talked about, such as kind of making sure that there's coordination across groups, coordinated kind of monitoring, data management, and that sort of thing, I think has already come up. But yeah, that was kind of the gist of our conversation.
Okay, thank you very much, Jayme. That was super helpful. The same questions were also posed to room Q2B, which Carly was facilitating. You guys ready to report out?
Yeah, absolutely. So we echo a lot of what was already said. Funding is huge, including equipment and staff time, as well as laboratory funding, ensuring that there's standardized processes for comparable data. And then also that nexus of using that data to then inform the management decisions and having a better understanding of what that data is actually telling you, as well as better data sharing and a shared repository, and kind of looking back at our historical data to help inform how we may change monitoring or inform the new monitoring strategy, or how we might use that as some of that baseline data to sort of figure out where we want to go next. And then as well, identifying laboratories with capabilities to do set analyses, and then getting that buy-in from management. So getting them to support technical staff committing time to it, as well as helping identify some of those management goals and questions, so that we can better understand what those data gaps are, so that that strategy can make sure that it's filling that. As well as making sure all of that data is shared in real time. And how that looks like, not sure, but making sure that it's one comparable with similar SOPs and QAPs, and then making sure that data is shared quickly and efficiently so that it can be used for response. So with that as well, coordination, having a response plan in place, whether that is reliant on MOUs or what that is, but having everyone have a role and responsibility. And I think those were some of the main points. The group wants to speak up. If I missed anything, go for it.
Excellent, thank you. That really actually that ties in heavily to tomorrow's conversation as well. So definitely more discussions to be had on that. Okay, last question, going the wrong way. In-person facilitator is Ted Flynn.
Okay, so our question was about how can HABs monitoring be incorporated into existing monitoring programs in the Delta? How can the monitoring be improved or changed? Missing any existing monitoring programs and partners, and information needed to be able to plan new research. So I think one of the big things we talked about to start things off was the importance of the types of how HABs monitoring to be integrated in these programs is going to depend on the management questions that are relevant to the different agencies that are going to be doing it. And so that was really important in that, obviously, as we know, different agencies have different mandates and different reasons for being. And so we're not going to have like one HABs question to rule them all. So kind of tailoring things so that they fit within the different agencies' responsibilities while being cross-compatible as much as possible. Some folks brought up that these different management needs kind of currently hamper some of the data collection that we do. And so people choose different methodologies. There was a discussion about how different methodologies that are driven by those management needs make it hard to integrate those data sets after the fact. And so some people said it's even difficult to know what monitoring programs are there, who is going where, when, and there's not really a central location, so that if you even were building something like that, you might not even know where to start. There's so many different, entities out there collecting data, doing different things. So that could be a challenge. We also discussed about how HABs monitoring itself can be technically challenging, and it might be difficult to integrate into existing monitoring programs that aren't already doing phytoplankton monitoring, that aren't familiar with that type of data collection, and that even something that might seem relatively simple, like a visual index, can still be really difficult if you are even in small changes in the methodology can result in data sets that are very different. And we also brought up the fact for coordinated and regular information exchange, you know, that things like this workshop are really valuable, but you know, that it can't be a one-off, that we need to have something that are periodic where we all get together, exchange information, give people updates. So we had several different things that we talked about during the how can the monitoring be improved. We talked a lot about remote sensing and the need to do better at kind of collecting a lot of data using either satellite imagery. People brought up potentially using drones and that type of thing. So that was really interesting conversation. And so yeah, we had a lot of other stuff. That's good.
Awesome. Also, I feel like good setup for tomorrow's conversations too. Okay, so I'm going to go to the virtual rooms on this. First up is Q1A, which is Rosie's room.
Hi, folks. I think we're probably going to repeat a lot of the themes that have come up already, but in terms of how HAB monitoring can be incorporated into existing monitoring programs, the three sort of key things that we came up with that would really allow more HAB monitoring to be added is having a mandate, which comes along with funding, providing resources in terms of funding and staff. While it sounds, oh yeah, you can just go out and get an extra bottle of water, that can actually be a lot for a group that's already collecting 20 bottles of water. And providing training. A lot of people have started implementing some sort of program without really having background training and cross collaborating, like Ted was saying, making sure that methods are comparable across groups. And that was another big thing that we had under the second part of the question, how can monitoring be improved or changed, is and what information do you need to be able to plan new things, is having guidance and training, having standard procedures, cross-calibrating between sampling programs, between labs, knowing how many samples do you need to really characterize a bloom, how frequently do you need to sample, what's the spatial stratification that you need, which methods should you be using, what do you even do with the data that comes back from spats. Having guidance and standard procedures on all of that, standard quality assurance project plans, etc. The other thing in terms of how monitoring can be improved or changed, you know, different sites is one of the examples. The number one thing is to decide what question of interest we're really honing in on and figure out which monitoring locations are needed based on that question of interest. Are we going to track hotspots? Are we more interested in public health or the ecology? Are we interested in understanding the bloom or just communicating with the public on when things are toxic? And investing in new tool development. Either picking up tools that other groups have developed and gotten honed in on that we just haven't used here yet, or putting in a little extra research to figure out how we can use things like flow cytometry in situ and some of the different boat-based test strips or test kits that you can get really rapid toxin data on. Looking at eDNA and some of this remote sensing, there's a lot of tools out there that we could be using that we're not yet, but we need resources and staff to do it. In terms of existing monitoring programs or partners, there could be a lot to be done, as other people have already said, on the citizen science front, communicating with the local businesses, with local stakeholders and NGOs, and with tribal organizations to make sure we have everyone who could be helping us out on this. The other information, what we need to plan new research that we identified was which taxa are really the problem children in the system. We all know about Microcystis, but there's other cyanobacteria out there that we monitor and we observe, but we don't really know if they have been causing problems and if we should be concerned about their presence. I think that's it.
Okay, thank you very much. Yeah, it's like the universe of HABs that Peggy presented on earlier. It's definitely something for us all to consider. And then our final group is Q1B, which was led by Maggie.
All these monitors are looking the wrong way. Yeah, I think for our group, and anyone else that was on the group, feel free to chime in. I think we also repeated a lot of what was discussed already here. But for the first question, how can HABs monitoring be incorporated into existing programs? We kind of thought through it or at least our brainstorming led to kind of a three-pronged effort. One was to start by assessing existing programs and seeing, kind of doing some sort of evaluation to see how we could best leverage them or how we could best, modify them or change them. But we also thought as part of that, we really need to assess what are the resources needed. So what staff, what training, what equipment, what else, including funding, might be needed for these programs to really make a difference. And then the third category of brainstorming ideas fell into considering regulatory mechanisms that might be needed or that might already exist, what funding needs, where they might be, I guess, addressed or where we could get funding for some of this. And then there were some legal liability questions that might need to be considered too, which we can talk more on if we want to elaborate on that. The second question was, how can monitoring be improved or changed? We kind of had three different groupings of ideas that we discussed. The first being, we really need to identify what we need to monitor, why we need to monitor it, what the best protocols, methods, tools might be for this monitoring, and also how to share the data that comes out of the monitoring in an accessible and central way. The second idea was really focused on developing models and decision support tools to help us focus our efforts, prioritize geographic areas, for example, and be more efficient in whatever monitoring we do. And then the third thing was really focused on how communication and transparency among monitoring programs and agencies will be really critical if we're going to improve coordination and participation. So just kind of thinking through how communication can play a big role here. I think for the third question, the second sub-question, are we missing any existing monitoring programs and partners? I think we talked about a lot of ideas, and I think we heard a lot of these ideas already. So tribal groups, voting community, NGOs, public health agencies, local agencies. One thing that's kind of a newish idea that I don't think we were maybe heard in some of the other groups was we had a long discussion on how important it would be to network with local universities and colleges and really get some partnerships developed, maybe through fellowship programs, for example, to connect students and labs with funding programs like fellowships, but also with questions that agencies have and with the data that's being generated through this monitoring, because these students could, do some projects and help us address some questions that we have using the data, capitalizing on the data that we're collecting. The last question, what information do you need to be able to plan new research? We had a lot of different ways we could answer those. A lot of them have already been said. One of the first things was what funding is available, because we can't plan new research unless we know what funding we have for it. But what new tools, techniques, and methods might be available to us? What could improve our monitoring or data collection efforts? And then I think the last thing, it would be useful to have a strong understanding of what we do know and what data gaps remain in terms of drivers, ecological drivers of these blooms, but also lots of different things going in. How is climate change going to affect them? How is like what's causing them to create toxic or produce toxins? But we wanted to also recognize that we should build on existing work, because it's not like we're starting from scratch. There are some existing synthesis documents that out there that we could build upon and that could grow to help us with that. And I think the only other thing, I think we already emphasized it enough, but under additional, if that's the only other thing that we had was we really need to identify some additional potential funding mechanisms to fund work and provide the necessary resources. So.
Excellent, thank you. Yeah, it's really great to hear all these responses. A lot of these things are things that we as a planning team over the last year have also been thinking about and talking about a lot as well. So we're doing excellently on time. I don't have a whole lot more for today. Thank you everyone so much for your participation today. We covered a lot of territory, I know that. And we had a lot of material, and tomorrow we have just as much. So tomorrow's theme is data sharing and integration. We have many more presentations and another panel lined up for tomorrow. And we're going to go ahead and continue this discussion then. Thank you everyone for your time, and I look forward to seeing you tomorrow.